This is class 12th RD Sharma solution. We are taking increasing and decreasing function. Exercise is 17.2, chapter is 17. Now, in any of the question which we are discussing, there are certain things which will be used in all of the question which are coming. So before that, going to the question, let us take the concept. We have two numbers A and B. Now when we multiply, if it is greater than 0, what does it mean? When A and B both are greater than 0, like we have 2, one number I am taking as 2, the other one is 5, you multiply it, it will be greater than 0 because 10. Or both of them are negative, that is minus 2 into minus 5 is 10. So this is only possible when both are positive or both are negative. So this A and B has certain relationship here. A is less than B. So when we take the factor, that is, if we have two factors, say x minus a and x minus b, and we are saying this is greater than 0. With this discussion we just had, x minus a should be greater than 0 or x minus b should be greater than 0 together. A and b I multiplied there. So here the factors are there. Or we have both of them less than 0. X minus a less than 0, x minus b less than 0. So this a less than b means what? Now understand it using the number line. So this is a, this is b. I am saying a is less than b. From left to right it is negative infinity to infinity. Now x minus a greater than 0 means what? Any value which is above a, all these values. X minus b less than greater than 0 means all the value above b. So what is the common point or common values? The common values is b greater than 0. Okay, so we have this final relationship is the x should be greater than b. Alright, now for the second condition where both are less than 0, this is minus infinity to infinity. This is a and b, a is less than b. X minus a less than 0, that means all this area. X minus b less than 0 means all this area. What is the common area? Anything which is less than a, any value which is less than a. So x less than a. Now we have to take all the values. So x minus a into x minus b greater than 0. So either x is greater than b or x is less than a. So this is the first condition. The second condition which we just discussed is x minus a into x minus b if it is less than 0. That is, if a is less than b and a into b is less than 0. What does it mean? One has to be negative. That is, one is negative, one is positive. Minus 2 into 5 is negative 10, less than 0. And 2 into negative 5, which is again minus 10, which is less than 0. So this a less than b, if we consider a less than b, and if x minus a into x minus b has to be less than 0, one has to be negative. So this is x minus a greater than 0 or x minus b less than 0, one case, or x minus a is less than 0 and x minus b is greater than 0. Now let us take the number line to find out the actual solution. In number line, things becomes very clear. So we have negative infinity to infinity. See, x minus a is greater than 0. That is all this area. X minus b is less than 0 means anything which is less than b, all this area, right? So this is what is the common point? We'll just come back to this, but let us complete this one. X minus a is less than 0 and x minus b is greater than 0. So we have this number line. We have this minus infinity to infinity, and this x minus a less than 0 means anything which is less than a, all the values less than a, and anything which is greater than b. So we always take the common point. So what is the common point here? If you combine this common point, only values which are between a and b are the solution for all this, right? In the first part we saw x greater than b and x less than a is the common solution. Here also common solution is x should be between a and b. So whenever the question we have factors, as I have told you everything, just write this: x greater than b, x less than b in case of first. In second case, x has to lie between a and b. This is the whole scenario you should understand. Alright. So this x should be between a and b if x minus a into x minus b is less than 0 and x minus a into x minus b greater than 0, x is greater than b, x is less than a. Now we have fx is equal to 10 minus 6x minus 2x square. So this 10 minus 6x minus 2x square, increasing or decreasing? First of all, why do we need differentiation for increasing and decreasing? So we are going uphill or downhill. The best way is to find a tangent or draw a tangent at that point. If the slope or the tan theta or the angle is positive, that is tan theta is positive, it is increasing. If tan theta is negative, that is decreasing. And what is tan theta? Tan theta is nothing but f dash x. What is f dash x? It is simply dy by dx. So tan theta or slope, dy by dx, all those are synonyms actually. They are same, similar, identical. So when we differentiate this fx, what are we going to get? F dash x greater than 0, that means the function is increasing, that means the slope is positive. If f dash x is less than 0, that means the slope is negative or the function is decreasing. So that is why we need to find out dy by dx, we need to find out the tan theta or the slope. So f dash x will be what? So differentiate this, we get minus 6 minus 4x. Alright, now you will see in various literature and people have been solving it and they will say 6 minus 4x equals to 0. Find out the value at what x equal to 0 and just locate that point on the line and take a value which is just lower than that value or higher than that value, put it and find out the increasing and increment and decrement. But this hit and trial won't work in mathematics. In mathematics, we need concrete solution. So if you see here, if it is increasing or decreasing, we have to see whether it is greater than 0 or less than 0. So f dash x is greater than 0, that is minus 6 minus 4x is greater than 0. What does it mean? Minus 4x, 6 I am taking here. It will not matter the angle sign. It will be greater than only. Now here x, now we have to multiply by negative in order to get the value x. So better is to multiply by negative 1 both sides or negative 1 by 4 both sides. So whenever we multiply negative on both the sides of the inequality, the inequality changes. The greater than will become less than. So what do you get? 6 by 4 is 3 by 2. Negative is already there. So it will be minus 3 by 2. So x is less than negative 3 by 2. What does it mean? That is when you go to the number line, now you can go to the number line and the answer is also with you. That is anything which is less than negative 3 by 2. That point, the function is actually increasing. So we start with negative infinity till positive infinity. We have a value which is minus 3 by 2, that is minus 1.5. So x less than minus 3 by 2, that is value which is less than, it can go up to minus infinity. It can go up to negative infinity. So x should belong to negative infinity to minus 3 by 2. Alright. So this is increasing and this is the interval in which it is increasing. In which interval it is decreasing? Same thing. F dash x should be less than 0. Same thing you have to do. Minus 6 minus 4x. Only the inequality will change. That is, previously it was greater than 0. This is less than 0. Again minus 4x. 6 goes here. Let us multiply both sides by negative 1 by 4. When we multiply by negative 1 by 4, as I suggested, the inequality will change. So minus 1 by 4 when you multiply, this minus 4 will get removed and you multiply minus 1 by 4. The angle sign is going to change. So it should be greater now. This is minus 3 by 2. So anything which is greater than negative 3 by 2, all those points, the function will be decreasing. So if you start with negative 3 by 2, you will go up to what point? You will go up to positive infinity, infinite. That is, you start with negative 3 by 2 and it will go up to infinite. So x will belong to minus 3 by 2 till infinity. In this interval it is decreasing. So it is increasing and decreasing in these intervals respectively. Now how you are going to solve it? Because I gave you the explanation and the logic, but you have to do it like this. Now it is very easy now for you. All of the questions are exactly like this. It is just a repetition. I would encourage you to solve all these questions by yourself. I will solve this one again, x square plus 2x minus 5. So we will do f dash x. It will be 2x plus 2 and this 2x plus 2. So first we will find out the increasing and decreasing. Rather we'll do them together. F dash x should be greater than 0 for increasing. That is 2x plus 2 should be greater than 0 for increasing. So that means what? Just divide both sides by 2, take 2 outside and then divide by 2. So when you divide by 2, it will be x plus 1 is greater than 0, that is x is greater than negative 1. So this again, let me tell you, number line is very important. So anything which is higher than negative 1 will give you the function which is increasing. At all those points, the function will be increasing. So it should belong to negative 1 to positive infinity. Here it is increasing. What about decreasing? F dash x should be less than 0. Same thing here. 2x plus 2 should be less than 0. Now divide both sides by 2. So x plus 2. No, this is x plus 1. Sorry. X less than negative 1. So it is saying anything which is lesser than negative 1 and it goes up to where? To negative infinity. So x should belong to minus infinity. It should start from negative infinity till negative 1. Here it will be decreasing. So here increasing, here decreasing. Now how are you going to write it? This is the process which you have to follow. Now you know all of these because this is simply the quadratic equation and this one is a cubic form. So we have just seen the quadratic form. Now this is the cubic form and there will be no change. The procedure will remain the same. We are going to differentiate and we are going to find out the roots and then we'll see how it is less than 0 and greater than 0. So if you remember the first thing which I told you or the explanation I gave, that is what you are going to adopt here. So you have f dash x which is equal to, I am differentiating now. So it will be 6x square, here 12 into 2, 40, 24, x, here 18, 15 will be 0. So this is f dash x. Now let us take the 6 out, because we can see everywhere it is 6. So I'm taking 6 out now, x square minus 4x plus 3. Now take the root. You know how to make the root? So I always see this first and last number. 3 and 1 is there. In order to form 4, we have to just add these two, but in negative, because we need negative 4. So it will be again x square minus x minus 3x plus 3. That you can follow. X you can take out, x minus 1 here, you can take minus 3 x minus 1 again inside. So x minus 3 into x minus 1. So this is the factor. You don't have to worry about 6. It is always a constant. It is positive. Now we will adopt the same methodology which we explained earlier. So if it is increasing, I am making this arrow for increasing only. I am not writing increasing again and again. It's increasing. This arrow is increasing. That is f dash x should be greater than 0. So multiply this 6 into x minus 1 into x minus 3 greater than 0. 6 you can divide both sides. So this 6 will be eliminated. So x minus 1 into x minus 3 greater than 0 means what? We are talking about x minus a into x minus b greater than 0. And a is what? If you put x minus 1 equal to 0, x will be 1. If you put x minus 3 equals to 0, it will be x equal to 3. So we are talking about a and b, 1 and 3. So a is less than b, 1 is less than 3. So you will directly write this. It should be x less than 1 or x greater than 3. This is the straightforward solution. Now coming to the number line here. So we have less than 1 and greater than 3. So this is 1, this is 3. And less than 1 means anything from 1 till negative infinity. This will tell you x belongs to negative infinity till 1. This one. The next one is anything which is greater than 3. 3 to infinity. That is x greater than 3. X belongs to 3 to infinite. So how are you going to combine these two solutions? You just have to take the union of it. So union means plus only. We are combining both the condition into 1. So it should be negative infinity to 1 and 3 to infinite. Union in between. So anything which is not between 1 and 3, the function is going to increase. Now you can very well indicate or assume that anything which is between 1 and 3, it has to be decreasing, because if you mark the plus as increasing, if you have left as increasing, right it is increasing, the part which is in between, it has to decrease, the function has to decrease. So I am going to tell you the decreasing function here. So the function is saying in which interval it is increasing, in which interval it is decreasing. So you have to show both of them, where or in which interval it is increasing and which interval it is decreasing. This is f dash x which is less than 0. So this 6 into x minus 1 into x minus 3 less than 0. You can again divide both sides by 6. So we have x minus 1 into x minus 3 less than 0. So if a is less than b, 1 is less than 3 of course. So the direct solution is x should be between a and b. That is, it has to be between 1 and 3. So x belongs to 1 and 3. This is the set. So these are the two solutions for increasing and decreasing function. Alright, so you should use the number line in order to show the examiner that you know how to solve it. Now this is the solution for your reference, which you can follow. Step by step, everything you have to write, and this is the way we have to go about it or follow this procedure. This is f dash x greater than 0, this is f dash x less than 0. Find the interval in which the following functions are increasing or decreasing. Now what do you see here? So we will differentiate. Same thing, you can just do it by yourself also. So f dash x is what? It is 5, 0, 36, x is 36, 3 to the 6x, and here you have 3 to the 6, 6x square. Now you can take minus 6 common. When you take negative 6 common, we always write as ax square plus bx plus 6. So when you take this negative 6 common, it will be x square minus x minus 6. Now you know that 6 is 3 to the 6. So 3 and 2 will give you negative 1. Minus 3 plus 2 or 2 minus 3. In whichever way you want to write. So it will be x common x minus 3 plus you can take 2 common x minus 3. So the factor will be x minus 3 and x plus 2. Now put them as 0. X is equal to 3 and x equals to negative 2. These are the critical points that you get. We call them as a critical point wherever this becomes 0, right? But there is a negative 6 also outside. Please remember. So x is equal to negative 2 as I just indicated and x equals to 3. So minus 2 and 3 are the critical points that you are going to actually mark on your number line. Now let us come here. So we have the increasing and decreasing, so we'll do them together so that you understand how we are going to do them. So f dash x should be greater than 0. Here we have f dash x should be less than 0. And what is f dash x? This one, negative 6 into x plus 2 into x minus 3, and this is greater than 0, and I'm showing you the decreasing one, minus 6 into x plus 2 into x minus 3 less than 0. So this is by the definition of increasing and decreasing function. So if you multiply both sides by negative in the inequality, then equality sign sign will change. If you multiply or divide anything, any side, both sides by negative, divide both, then the inequality will change. That has to be kept into your mind. So now multiplying both sides by, or you can say divide both sides by -6. So whenever we divide by negative, it can be any number, the inequality will change. We are trying to eliminate this -6. So the inequality is going to change here. X plus 2 into x plus x minus 3 is less than 0. Here we have x plus 2 into x minus 3 greater than 0. So we have explained it already, or we have seen the explanation. Now we can directly write the answer here because it is now quite clear. X plus 2 and x minus 3 multiplied greater than 0 means x should be, which one is lower, which one is higher. Please remember, -2 is lower and 3 is higher. So minus infinity to minus 2 is one interval and 3 to infinite is another interval, which I can very well say. You can also say that. So A and B, I told you, A is -2 and B is 3 here. A is less than B. So x is less than -2 and x is greater than 3. What about this one? It has to lie between -2 and 3 as previous discussion has commenced. So that means if f dash x is greater than 0, then the value between -2 and 3, all these value, the function is going to increase. And from 3 to infinity and from -2 to -infinity, it is going to decrease. So when you are going to combine them, how are you going to write? Let me show you again. We are talking about -2 and 3, or everything on -2 side on the left, that is from -infinity to -2, it's going to decrease. And on the right side, 3 to infinite. So we have x belonging to minus infinity to -2 and x belonging to 3 to infinite. Now when you combine these two, it is going to be -infinity to -2 union 3 to infinity. So I hope you got the idea. This is the solution, where it is increasing, where it is decreasing. So this is how you're going to solve it. I hope you have a better idea now. So this I am rounding, which is the solution here, and this last one, the rightmost. How are you going to write it? So this is the way you are going to write, and you have to complete it, or you can make two cases also. Like first you show the increasing, then you show the decreasing, and you have to make the number line again and again. I'm reiterating, and this portion I've already explained. Okay, this question is also almost similar to the previous one. So I will show you the reference solution so that you can go ahead with your solution. Here also similar thing, no more explanation needed because already being discussed. Two questions we have taken it like this with elaborated discussion. Here also, this is also the cube one. See here, again same thing. If you have any problem, just let me know. We can discuss on that. But I hope that you guys are quite motivated and intelligent. So you'll be able to complete all of these. Again, the cube one, let us go ahead. Next one, same thing. I will go past it again. But the reference I am giving for every question so that if you are stuck anywhere, you can just refer to it. Because the time is limited, we have to complete these many questions. Again, this is quite simpler. There is no x square term. It will be easier for you. Again, the cube one, you can also do that. So you can just go ahead. And this one, find the interval in which the following function are increasing and decreasing. So this is exactly similar to what we have done already. The difference only what you see is the factor is already been made. So we have to make it as what we have seen in the earlier question, that is multiply. So I am multiplying it. Fx is equal to x minus 1 into x minus 2 whole square. This a minus b whole square is a square plus b square minus 2ab. This is x square, this is b square, so 4 square, and minus 2 into x, that is 4x. Now just multiply this, and I hope you'll be able to multiply. This is just a proper common multiplication. You'll get x cube minus 5x square plus 8x minus 4. This is what you'll get. Now this is what we have already seen in the previous questions. So we will take the differentiation now. F dash x is the differentiation. So this will be 3x square minus 10x. So I am differentiating each term. I am differentiating. That is dy by dx. That is f dash x. So this will be 8, 4 will be 0. So 8 is a 24 it is. So how do you get 10 from this? So 6 4 is a 24. You can also use this 6 and 4. 3x square. You have minus 6x minus 4x plus 8. Now you can take 3x common, x minus 2, here also you can take, this is 6x square actually, minus 4x minus 2, x minus 2 into 3x minus 4. So what do you get? X minus 2 equals to 0, and so x equals to 2, and 3x minus 4 equals 0, that is x is equal to 4 by 3. So this x equals to 2 and x equals to 4 by 3. These are the critical points. So this critical point will tell you on the left or on the right, where this curve is increasing or decreasing, or these are the intervals. There are different intervals where the function is increasing or decreasing. So let us start with the increasing one. Increasing is f dash x should be greater than 0. That means x minus 2, 3x minus 4, this should be greater than 0. Now which one is lower one? I told you in the previous discussion that we have a less than b. So we can directly write the answer. So what we will do? X is equal to 4 by 3, x is equal to 2. So this I am writing first, 3x minus 4, because 4 by 3 is lower than 2. Now put it on the number line, keep it on the number line. This is 4 by 3, it will be lower than 2. This is negative infinity, this is plus infinity. So when we have two factors, when we multiply, it has to be greater than 0. This means what? You will take these two areas, and this have already we have established. So I'll write the answer directly. X should be less than 4 by 3, or actually and, it should not be and, or it should be and. X greater than 2. X is less than 4 by 3 means what? And x is greater than 2 is what? X should be in between, because anything which is level lower than 4 by 3 is negative infinity. So you are from negative infinity to minus this 4 by 3 plus 4 by 3, and you can just union it, combine it with 2 to infinite. So this both is the union, and this is the solution for increasing one. Now coming to the decreasing one, f dash x should be less than 0. So 3x minus 4 into x minus 2 should be less than 0. Again, we have already discussed. So x should be between the lower one and the higher one. 4 by 3 is the lower one and 2 is the higher. So x is between 4 by 3 and 2. So x, you can call it as x belongs to 4 by 3 and 2. So this is your solution. Now you can just, making a number line is always good in order to complete your solution. So this is 4 by 3. This is 2. So anything which is below 4 by 3 and above 2, this is increasing. So it will be plus minus plus, because it is increasing. Wherever it is increasing, we write plus, and wherever it is decreasing, we write negative. So negative is just a symbol. So how are you going to write it? This is the procedure you need to follow, and this way you have to go ahead. So the next question, so 1.16, that is, we have already covered 16 questions, and most of the questions that we have covered are like this only. So I'm going to show you the reference solution. Same thing here, similar question, there will be no difference, only there will be certain calculation that you can always do. Now this is a different kind of question which you see. It is not very different, but the initial thing which we perceive is something different, and especially we have certain denominators here. The solution should be on the same track. The procedure we are going to follow is the same. The first thing what we do, that we are going to eliminate the denominators. 10, 5, all these we can just get rid of. How are we going to do that? We are going to take the LCM. So we have 5, 5, 10, and you take the LCM. What will be the LCM? If you take the LCM, it will be 10. So when you have this LCM, you see 10 divides by 10 by 1. So you multiply 1 with 3x to the power 4. 5 divides 10 by 2. So you multiply 2 with 4x cube. So it will be minus 8x. When there is nothing in the denominator, so you just multiply 3x square with 10. You have 5 2s are 10, 5 2s are 10, so 2 into 36x will be, so it will be 72x. And again you have 11, so there is nothing in the denominator of 11, so you have to multiply directly 11 with the 10. So it will be 110. So I have written 10, it will be 110. There is a slight mistake, you can just correct. And I am 1 by 10, I am taking outside. When you differentiate this, I am differentiating now. 12x cube minus 24x square minus 6x plus 72. The last one will be, that was 110, is going to be 0. Alright. So what you can take outside, if you take 12 outside, because 12, all the values which are in front of the x, they are all divisible by 12. So when you take this 12 by 10 you can take outside. So even if you keep it, you can write it as 6 by 5. It's up to you, because we are going to deal with the next part, which is the variable part, the terms having the variables. So now when you take 12 outside, what will be remaining? X cube minus 2x square minus 5x plus 6. This is 6 by 5. If you divide these two, 6 by 5. We are going to take this in just a while, but this x cube minus 2x square minus 5x plus 6. So we are going to take the factors of this. Now normally we put 1, -1, 2, -2, normally, and when we have this negative values, you can put any of these. Whenever you have plus sign in between this, means if you have the term or the expression which has a positive, don't try putting negative, because it won't work normally. But here let us say that we put x equals to 1. So 1 if you put, you will get certain solution. If you get a 0, that means x is equal to 1 is satisfying. So x minus 1 is a factor. So just take 1 because they are negative in between. So you have 1 cube minus 2 into 1 square minus 5 into 1 plus 6. So 6 plus 1 is 7. 7 minus 7 is 0. So this 7 minus 7 is 0. So you get x is equal to 1. X minus 1 is the factor. So there are various questions that are going to come of this sort. So I am going to divide it. If you want to find more factors, you have to divide this x cube minus 2x square minus 5x plus 6 divided by x minus 1. So this 1 minus 1, 2 minus 2, all these are just hit and trial. You should know the way of finding the factor that we have already discussed in previous discussions. So you just write this x cube minus 2x square minus 5x plus 6. We are dividing it by x minus 1. So this x minus 1, now you can write x square here. So x into x square is x cube, minus 1 into x square is minus x square. Now subtract. Well, when you subtract x and x cube minus, with that gets cancelled, you have minus x square minus 5x plus 6. You need minus x square, so you have to multiply x with negative x. You get negative x square plus x. Now again change the sign because you're subtracting. This gets cancelled and this minus 5x and negative x will be negative 6x. So negative 6x plus 6. This you already know. I'm just doing it for the sake of completion. And you need negative 6x, so just multiply it by negative 6. So negative 6x plus 6. You can just change the sign and this will be 0. So it will be x square minus x minus 6. And again you have to make the factor of this. 6 is of course 2 into 3 and 2 and 3 will give you 1 because there is 1 in between. So x cube minus 3x plus 2x minus 6 you can write. X you can take common, x minus 3. You can take 2 common, x minus 3. So x plus 2 into x minus 3. So you have 3 factors here. X minus 1. We have not completed. We have just made the factors. We have not just yet reached increasing and decreasing discussion. So x minus 1, x plus 2 and x minus 3. What are the critical points? Just put this equal to 0. So x equals 1, x plus 2 equals to 0, x is negative 2. X minus 3 equals 0, that is x equals to 3. These are all the critical points. That is, in these interval, these are critical points which makes the intervals. And in these interval, the function may be increasing, it may be decreasing. So this kind of question we have not done earlier. So f dash x is greater than 0. So let me tell you, there is a standard solution here. And for f dash x less than 0 with 3 factors, it's a standard solution. 12 by 10 is already there. So you are just doing 12 by 10, 12 divided by 10, x minus 1 into x plus 2 into x minus 3 greater than 0. So when you put greater than 0, you just represent it on the number line first. And I'll tell you the standard solution. If you are aware of this, then it's okay. Otherwise, I'll tell you just now. So I am writing all the critical points here. And this is 1, negative 2 and 3. I already told you from left to right, negative to positive will commence. That is, lower value will be on the left and on the right it is going to be the higher number. So when you have f dash x greater than 0, so anything which is greater than 3, that is 3 to infinity, is your solution. And on the left, because 0 is which I have put in here, 0 is not there, only negative 2 and 1 is there. So negative 2 and 1, this is the point where it is going to be increasing, and 3 to infinity it is increasing. I hope you got the idea. Anything which is 3 to infinity is increasing, and between negative 2 and 1 it is increasing. How about f dash x less than 0? So same thing with less than 0. I'm not writing it again. I'm just saying that you have to write it with less than 0. So you have the solution as anything which is lower than negative 2, that is negative infinity to negative 2, and between 1 and 3. So same thing, means you can just take the analogy. In f dash x greater than 0, it was anything greater than 3 to infinity, and f dash x less than 0 means anything which is lower than negative 2. So negative infinity to negative 2 it is. Minus infinity to negative 2. And what is the other interval on the rightmost interval is 1 to 3. So you just write 1 to 3. How are you going to solve it if you are solving it by yourself? This is the whole procedure which we discussed, and these intervals have to be made. So these are different intervals. So 1, 2, 3, 4. 4 intervals are there. And these intervals, I told you where it is positive or increasing, where the slope is negative, it is decreasing. So if it is greater than 0, then 3 to this first is the leftmost interval. Don't worry about negative infinity, positive infinity. Negative 2 to 1 and anything on the right of 3. So it's 3 to infinity. So this minus, and how about decreasing? Minus 2 to infinity and 1 to 3. Find the interval in which the following function are increasing or decreasing. Fx is equal to x raised 4 minus 4x. So let me just solve it. So I'm just doing the f dash x, that is the differentiation. X raised 4 is 4x cube minus 4. Now critical point, just put this as 0. Means expression equal to 0, that will give you the critical point. So when you take 4 outside, it will be x cube minus 1. X cube minus 1. When you take greater than 0, it is increasing. When you take less than 0, it is decreasing. So let us start first with f dash x, which is greater than 0. So 4 into x cube minus 1. See, in the next previous question, when we were taking greater than 0, less than 0, just divide both sides by 6 by 5 or 12 by 10. That will eliminate that constant. So don't worry about the constant at all. Here, when you do this, 4 into x cube minus 1 greater than 0, divide both sides by 4. When you're dividing by any positive number, the inequality sign won't change. So when you divide it by 4, x cube minus 1 is greater than 0, x cube is greater than 1, and x cube is greater than 1 means what? X is greater than 1. X cube greater than 1 means x is greater than 1. Okay, so that is 1 to infinite. Anything which is greater than 1, it goes up to infinite. So x belongs to 1 to infinite. Here this function is increasing. How about decreasing? F dash x less than 0. 4 into x cube minus 1 should be less than 0. Divide both sides by 4. You'll get x cube minus 1 less than 0. So x cube is less than 1. Anything which is lower than 1 is simply negative infinity to 1. If it goes from 1 above 1, it is 1 to infinity. Lower than 1 is negative infinity to 1. So x cube is less than 1, that is negative infinity to 1. X belongs to negative infinity to 1. This is the solution and answer. But we need to know how to solve it also. So this is how you are going to solve it. Now this question is almost similar to the question we have discussed in detail, if you remember. So let us do this question. If it was not clear, then we'll do this again, because this kind of question may come. It has various things to do. So f dash x, before that we have to take the LCM. So 4, 3, 2, how are you going to find the LCM? You know it already. I'm just doing it for the sake of people who can relate with it. So I've just divided by 2. You get 2, 3. There is no value which can divide all of these 2, 3, 1 at one time. So you have to multiply all of these. 2 into 2 into 3 into 1. So 2 to the 4, 4 is 12. 12 is your denominator, which is your LCM. Now what do you do? 4 3 is 12. If you divide 12 by 4, you get 3. You just have to multiply 3 with x raised 4 and write it here. 3x raised 4. Again, 3 divided by 4, 12 divided by 3 is 4. So 4 multiplied by 2x cube. So that is going to be 8x square, x cube. Now 2 6 are 12. So multiply 6 with 5x square. It will be negative 30x square. Now 6 divided by 12 is 2. So you have to multiply it by 2. That is, there is nothing in the denominator, sorry. So you have to multiply everything by 6 by 12 and 7 also by 12. Now you forget about this 12. 12 will come in front, and we will only consider or talk about the expression with what we have got. That will make our life easier. The question will be solved easily. So let us start it here. We have 12 x cube. I'm differentiating. So this is differentiation result. And this is minus 72. 84 will get eliminated. So you can take 12 common from here, as we have just completed the previous question. You can just take this 12 outside. So when you take 12 outside, it will be x cube plus 2x square minus 5x minus 6. You have 12 in the denominator also. Now you don't have to worry about the constant because they are already cancelled. Let us put x equals to 1 here. You won't get the answer. Now put x equals to negative 1. So minus 1 whole cube is minus 1. Here plus 2, minus 1 plus 2, minus goes this plus 5, and this is minus 6. So this is 7 minus 7. So it is going to be 0. So x is equal to negative 1 is the one of the root. So x plus 1 is the root actually. Now you have to divide x plus 1. You have to take the actual function, that is the differentiated, the function which is x cube plus 2x square minus 5x minus 6. That is the differentiated function, and divided by x plus 1 because we are interested in that function only. So the factors will come like this. I'm not going to solve that division part. You can do it by yourself. X minus 2 and x plus 3 will be the factor. What are the critical points? X is equal to negative 1. X is equal to 2 because I'm just putting it as 0. X plus 3 is equal to 0. That is x is equal to negative 3. Now don't worry about anything. The logic which I told you, that or you can just mug it up. So this, which is the lowest one? 0 is not inclusive. I'm just putting 0 just to locate other points. So negative 3, negative 1 and 2. So the interval is f dash x greater than 0 is, I'm just saying you have to write everything. So the interval is negative 3, negative infinity to negative 3, negative 3 to negative 1, negative 1 to 2 and 2 to infinity. So there are 4 intervals. 0 just forget about. And f dash x greater than 0 means it has to be greater than 0. F dash x less than 0 means same thing, less than 0. But you know already the solution, which we have already discussed. When it is greater than 0, first interval 2 to infinity it is going to increase, and negative 3 to negative 1. That is the rightmost interval including infinity and the leftmost interval without infinity. I told you x minus a into x minus b greater than 0 and less than 0 I already explained. So the same thing applies here, x minus a into x minus b into x minus c less than 0. So there are 3 factors now. So if greater than 0, anything above 2, it is increasing, and between negative 3 and negative 1, it is increasing. So this has come from the above discussion, which I did in the first exercise in the first question. When it is less than 0, so it has to be anything which is lower than negative 3, that is negative infinity to negative 3, and the rightmost interval. What is the interval? Negative 1 to 2. So x belongs to, I'm just showing you the less than 0. So x is negative infinity to negative 3. And I told you 0 is not there, but you have to take the rightmost interval. What is the rightmost interval? Without including the infinity. So you have to just see the critical point, negative 1 and 2. So it is union negative 1 and 2. X belongs to this. So this is how you are going to solve whenever it is x cube form. So this is how you are going to solve it. This is the solution for you or reference for you. So just note it and then we go ahead. So again, x to the power 4. You are well versed now and you know how the logic works here. Find the interval in which the following function are increasing or decreasing. So this fx is equal to 5x raised 3 by 2 minus 3x raised 5 by 2. X is greater than 0. So first we'll differentiate it. F dash x is equal to what? It's 5. This 3 by 2 comes here. X to the power 3 by 2 minus 1. This is minus 3. 5 by 2. X raised to the power 5 by 2 minus 1. So this is just simple differentiation. What is 3 by 2 minus 1? It's 3 minus 2 by 1, that is 1 by 2, and anything raised to power 1 by 2 is under root. So x raised half. And what about this one? This is 15 by 2. 5 by 2 minus 1 is 5 minus 2 by 2. That is 3 by 2. So this is x raised 3 by 2. So 3 by 2 is what? 1 plus 1 by 2. And when it is in the power, you can just write x into x to the power half. X raised 3 by 2 I have written like this. Now x raised half is there and 15 by 2 is also there common. So you can take 15 by 2 x raised half common. You'll get 1 minus this, you can just eliminate. Only x will remain. Now this f dash x will give you the critical points or the intervals where the function may be increasing or decreasing. So you just have to put it as 0 and find out where it is going to be 0. That is the point where it is changing its direction to increasing or decreasing. You know that x raised half, that is under root x equals to 0, that is x equals to 0. 1 minus x equals to 0 is equal to x, that is x equals to 1. So x equals to 0 and x equals to 1, these are two critical points. So we'll go ahead with 0 and 1. Now this is the number line. If I want to represent this is 0, this is 1. This is negative infinity, this is positive infinity. So we have to include 0 and 1 because we have got these two as the critical points. In increasing, f dash x should be greater than 0. So it should be 15 by 2 x raised half 1 minus x greater than 0. Now what does it mean? See, under root x raised half is nothing but under root x. And under root x means always positive. You cannot have a negative value. So it will always be greater than 0. 1 minus x greater than 0, that is 1 minus x greater than 0, this x is less than 1. That is under root x into 1 minus x greater than 0 just simply means both of them should be greater than 0, both of them should be less than 0. But under root x will always be greater than 0. So only 1 minus x greater than 0 is the main key. So this it has to be x less than 1. From here we got x less than 1. Again, let me tell you again, under root x cannot be negative or less than 0. So whichever thing is inside under root, it should always be greater than 0. So this x belongs to 0 and 1. 0 comma 1, because x is greater than 0, x less than 1. That means the common point is x between 0 and 1. This is f dash x greater than 0. Now coming to the next point, which is f dash x less than 0. So less than 0 means just put it as 0, less than 0. So 15 by 2 x raised half 1 minus x less than 0. Again under root x raised half, it cannot be less than 0. Only 1 minus x can be less than 0 because x is always in under root x should always be greater than 0. It is always positive. 1 minus x is less than 0. That is x should be greater than 1. So if x is greater than 0, x is greater than 1, what does it mean? It means what? It means x should be greater than 1. So what will be the solution here? X belongs to 1 to positive infinite. This is the answer. So this is minus plus minus where it is increasing or decreasing. Increasing we put plus, decreasing we put negative or minus. So this is the reference solution that you can follow in order to solve it and write it. And those who want to do by themselves, they can also do it like this. The making of diagram is very essential in these questions. Okay, please note this. We'll go ahead now. Find the interval in which the following function are increasing or decreasing. So we have f dash x, we'll find out. So let us find it directly. 8x to the power 7 plus this 6 to the 12 x. Now you can take this x outside, you will get x raised 6 here 1. Now when you take 4 outside, 4 to the 8, 4 to the 12. So when you take 4 outside, so you have taken essentially 4x outside. So inside what will be remaining? Here 2, here 3. So 2x raised 6 plus 3 and 4x. So now let me tell you about the critical points. When critical points are achieved when we put this as 0, this expression as 0. So either x is equal to 0 or 2x raised 6 plus 3 is equal to 0. So x raised 6 equals minus 3 by 2. Now this cannot happen. X raised 6 equals negative 3 by 2 is impossible. How? X raised 6 is nothing but x square to the power 3. X square cannot be negative at any cost. Whatever you put here, either negative or positive, it will always be positive. So you do cube or any number in that power, it will always be positive. So you just have one point, which is x equals to 0. So there is only one critical point in this question, which is x is equal to 0. So anything which is greater than 0 to infinite will be 1 increasing, and 0 to negative infinity it will be increasing. I will see where it is increasing, where it is decreasing. So in this f dash x greater than 0, so this is 4x, 2x raised 6 plus 3 greater than 0, and I told you about this one, so you just forget about this. It should be x greater than 0. So anything which is greater than 0 belongs to 0 to infinite. So x should belongs to 0 to infinite is one case. Now f dash x is less than 0. Same concept we are going to follow here, and f dash x is less than 0. Again I told you that x raised 6 equals to negative 3 by 2 is impossible. So anything on the right which is negative cannot have on the left as square power. So only x should be less than 0. Anything which is less than 0 goes from 0 to till end, and what is the end? It is negative infinity. So negative infinity to 0 is the interval where it is decreasing. This concept I already told you. So this is the only catch in this question. Otherwise you know it already. Now let me show you the reference here. The thing which I explained you has to be very clear. X square cannot be negative. That is why the final result which we got is 0 to infinity and negative infinity to 0. So this is increasing point and the other one was decreasing point. Now this x cube question we have already done. So we'll just go ahead with this and we'll pass this question because these questions has been attempted and being solved multiple number of times. There is no difference. The procedure will remain the same. There will be no difference here. So this question also is similar, but this kind of question can come in your exam because normally the examiner or the paper would make certain questions bit tricky. So if you have done your mathematics properly, then only you will be able to attempt it. So this is only one step away from what we have been doing. You just have to multiply this. That is x into x minus 2 whole square. Just have to multiply this. So multiply this x into x minus 2 inside first. You will get x square minus 2x and then you square it. So a minus b whole square. You will get a square plus b square minus 2ab. This is simply a square minus b square, a square plus b square minus 2ab. So x raised 4 and this is 2ab, 4x square plus, and 2x whole square is what? It is 4x square. 4x cube, sorry. So a square plus b square, 2x whole square is 4x square. So that we have already done. F dash x now. Now I'm just differentiating it. So it will be 4x raised 4 is 4x cube. So this is 4x cube. This is 8. 4 to the 8, 8x minus 4 to the 12x square. So this is simple differentiation which we have done. And there are things which we can take outside so that we can make proper roots here or the factors here. So I'm taking 4x outside, it will be x square inside, and I'm just swapping these two to make it the way we are used to see it. X square minus 3x plus 2 minus 3x can be achieved from 1 and 2, which is already there. So x square minus x minus 2x plus 2. You can take x common, x minus 2, you can take minus 2 common, x minus 1. So you have f4x, x minus 1 into x minus 2. So this x into x minus 1 into x minus 2. So when you put this equal to 0, you will get the critical point. So x should be equal to 0. X minus 1 equals to 0, that is x equals to 1. X minus 2 equals to 0 means x equals to 2. So these are the three critical points. So how many intervals you will get? Because it will start from negative infinity, it will go up to positive infinity. These are the different sets or interval which we need to follow. The negative infinity to plus infinity, what are the interval? Minus infinity to 0, 0 to 1, 1 to 2, and then 2 to infinite. So 1, 2, 3, 4. 4 intervals we have got here. And you can also write in your solution like this, that we have got 4 intervals because 0, 1, 2 were our critical point. So these are the 4 intervals which I have written. You should also write this. Next thing is f dash x. We are differentiating it. So f dash x should be greater than 0. That is 4 into x minus 1 into x minus 2 should be greater than 0. So I told you already, if you have 3 terms or 3 factors, both sides you divide by 4. So 4 will get eliminated anyways. So you have to talk about x into x minus 1 into x minus 2. When these 3 terms, 3 factors, when we multiply, so there will be certain combination, permutation, where it is going to be greater than 0. So I told you anything on the right from the last factor, that is 2 to infinite, and on the left 2 normal values which you got, that is 0 to 1 is one of the point or interval, and 2 to infinite should be the other point or other interval where you can just take the union. How about f dash x less than 0? Same thing has to be done leftwise, that is negative infinity to 0 has to be taken, and 1 to 2 should be taken. This way you will get to know if you practice it more. That is 0 to infinity, negative infinity on the left, and on the right you don't have to go to infinity, leaving infinity first interval, which is the first interval from the right. It's 1 to 2. So the leftmost interval and this 1 to 2. This is the answer. And how you are going to go about it. So these are the references for you. Again, this question we have already done like this. So I'll leave you with the reference so that you can try it out by yourself. And there are various questions which are coming which are almost like this. So I'm just skipping those until a question which has some explanation or something different which we can follow. Here also the denominator question we have already seen. Just remove this 2. It will be a normal expression which you just have witnessed in the previous discussions. So these are 3 factors and you know how to solve this. We have just completed one question with these 3 factors. So right, this question is somewhat different. So we'll just attempt this. So first thing is f dash x. Log 2 plus x is 1 by 2 plus x. Differentiation of 2 plus x is going to be 1 only. Then you have minus this 2x divided by 2 plus x. So I'm using the quotient rule here, 2 plus x whole square. Now 2 plus x in the numerator now, and differentiation of 2x is 2. Now 2x here and differentiation of 2 plus x. Differentiation of 2 plus x is going to be 1. So 2x into 1 again. So what do you get when you multiply the numerator here? So this is 2 to the 4 plus 2x minus 2x. So this 2x gets cancelled. So you will get finally 1 by 2 plus x minus 4 divided by 2 plus x whole square. So how are you going to solve this? See, we'll take 1 by 2 plus x common here. You'll get 1 minus 4 divided by 2 plus x, and when you solve this, you'll get 2 plus x minus 4 divided by 2 plus x. So this is 2 minus 4 is negative 2, x minus 2 divided by 2 plus x. So x minus 2 by 2 plus x, and outside you have 1 by 2 plus x. Finally, you'll get x minus 2 divided by 2 plus x into 2 plus x, which is 2 plus x whole square. Now this is the f dash x. So if it is equal to 0, then you will get the critical point. Please remember, x plus 2 in the denominator cannot be equal to 0. You cannot have anything in the denominator 0. So only x plus 2 should be equal to 0, x minus 2 should be equal to 0. That will give you x equals to 2. Denominator x cannot be negative 2. First thing you have to be very careful about. And second thing, x minus 2 has to be equal to 0 for the critical point. Of course, we'll see this f dash x where it should be greater than 0. So we just have one critical point. What is the critical point? I'm writing 0, but you don't consider that thing. I'm just marking it for the sake of convenience. Otherwise, we just have a 1 point 2. So anything greater than 2 to infinity, anything less than 2 to negative infinity, that is on left and right, that is the point where it is increasing or decreasing. So we have f dash x greater than 0. That means x minus 2 divided by x plus 2 whole square should be greater than 0. There is x minus 2 should be greater than 0. You just forget about this, because if you multiply both sides by x plus 2 whole square, you are going to get 0 anyways. So x should be greater than 2. Anything which is greater than 2, that means 2 to infinite. How about f dash x less than 0? X minus 2, x plus 2 square less than 0. So it should be less than 0. So x should be less than 2. So x greater than 2 is from 2 to infinite. X less than 2 means negative infinite to 2. So increasing here in the 2 to infinity interval, and this infinite to 2 in this interval. So this is the whole scenario here, and this is the reference which you can follow. And these all you have to write, because everything has to be written so that the examiner can understand. Determine the value of x for which the following function, this one, is increasing or decreasing, x square minus 6x plus 9. Also find the coordinates of the point on the curve on this where the normal is parallel to the line y equals x plus 5. Now if you see the previous chapter, that is chapter number 16, the second part is actually related to that one. So we have already done questions, lot of questions like this. The first part is of this chapter, so we'll combine them and try to form a proper solution so that we get the value of x. So first thing is fx is x square minus 6x plus 9. So dy by dx will be equal to, this is you have to take the differentiation, so it will be 2x minus 6. Now in order to find out the critical point, 2x minus 6 will be equal to 0. At what point it is increasing, at what point it is decreasing. So this 2x minus 6 equals to 0, that is x is equal to 6 by 2, that is the critical point is x equals to 3. Now if you see here, this is the critical point. So anything which is greater than 3, which is 3 to infinity, will give you something, and anything which is lower than 3, which is negative infinity to 3, will give you something. And let's just see what is that something. F dash x greater than 0 for increasing, f dash x less than 0 if it is decreasing. So we have 2x minus 6 greater than 0, that is x is greater than 3. So 3 to infinite, this is x belonging to this range or this domain. Then we can say that it is increasing in 2x minus 6 less than 0. So x is less than 3. So in the interval, I should not say domain or range basically. It's interval. So this is x belongs to anything which is lower than 3 is negative infinity to 3. So this is where we got it is increasing and decreasing. Now coming to the find the coordinates. So we are interested in x and y. We already found the slope. 2x minus 6 is the slope of the tangent. What is the slope of the normal? Minus 1 divided by dy by dx. That is dy by dx is nothing but the slope of the tangent. So we have normal parallel to the line y equals x plus 5. Y is equal to mx plus c. If I equate, we get slope which is m equals to 1. So slope is m is equal to 1. So this is nothing but dy by dx. No, this is not dy by dx. This is minus 1 by dy by dx, because the tangent, it is normal. We have to find out the tangent. So dy by dx is 2x minus 6. So it has to be equal to negative 1. How negative 1 will come? I am saying if you want to equate 1 with something, it has to be 1 equals to minus 1 by dy by dx. Or slope of tangent is minus 1 divided by, that is minus 1 divided by 1. 1 is the slope of the normal. So slope of normal is equal to slope of the line, which is already given in the question. It is not the tangent. So slope of the line is 1. Slope of the normal is what? Minus 1 divided by 2x minus 6, as I said. It will be minus 1 by dy by dx, and dy by dx is 2x minus 6. So negative 1 by 2x minus 6 is equal to 1. So 2x minus 6 is equal to, this is just multiply here. So 2x will be 5, x is equal to 5 by 2. So x is 5 by 2 here. Now what will be the coordinates? You already have the x equals to 5 by 2. So why not to put this in the original equation, which is y equals to x square minus 6x plus 9. When you put this, I am just replacing x by 5 by 2 in this equation. So when you solve this, y you are going to get as 1 by 4. So x was 5 by 2, y is 1 by 4. This is your coordinates. Now let me show you how you are going to write and solve it, because verbally I told you and the logic I explained, but how you are going to write is all here. Just follow this. Now there are a few questions related to trigo, that is trigonometry. We have find the intervals in which this sin x minus cos x, where 0 to x is between 0 and 2 pi. 2 pi is 360 degrees. So we are talking about increment and decrement, or increasing function and decreasing function in this interval 0 to 360 degrees. I am differentiating it now. F dash x is sin x will be cos x will be minus sin x. So it will be cos x plus sin x. Now if you want to find out the critical point, just put it as 0 and you will get cos x equals to minus sin x. That is, if you divide both sides, you will get basically 10x equals to minus 1. So basically 10x equals to minus 1 is the critical point. So you have to find out what is the x at which tan will be equal to minus 1. So let us start with this greater than 0. I am just taking this f dash x and making it as 0, putting the negative on right side, dividing both sides by cos. You will get 10x. 10x is greater than minus 1. Now add sugar to coffee. They are all sine, tan, cos. So in all the quadrants which all are positive. So tan is positive at first quadrant and fourth quadrant. Now tan x is greater than minus 1. What does that mean? That is the value of x at which, first of all, when it is going to come as 1, just start with the basics. See, tan x is equal to what? Tan x equals to 1. Tan x equals to 1 is at 45 degree. And tan 90 minus theta or tan 180 minus theta will be what? Because tan 180 minus theta will be negative tan, because it is negative in the second quadrant. So tan 180 minus 45, you can just write like this, because tan theta and tan 180 minus theta, they are complementary. So 135 degree, 3 into pi by 4. See, if you multiply 3 pi by 4 by 180 by pi, what do you get? This is 9, this is 45 degree, 45 into 3 is 135 degree. So one angle is 135 degree. So this is 135 degree. What will be the other angle? Here, it will also make the tan x, which is equal to negative 1. So we have 3 pi by 4, and I know that when I'm making a line, you know that this is 180 degree angle. So just add pi more. So you'll get 7 pi by 4. What I'm saying is, from 0 to this 135 degree or 0 to 3 pi by 4, this tan x is going to be greater than negative 1, and it will be less than minus 1 when you're going from 7 pi by 4 to 0. I hope you got the idea. Oh no, 7 pi by 4 to 2 pi, sorry. It's 2 pi, not 0. So 7 pi by 4 to 2 pi, it is decreasing. 0 to 3 pi by 4, it is increasing. I told you how you got it. Because if you know tan x equals to 180, it will be equal to 45 degree. You know when to add pi, when to subtract it by pi, so that you get a negative 1. So this is less than 1. What will be the less than 1? So again, see, tan x is greater than minus 1. You have to take both of them. 0 to 3 pi by 2 and 7 pi by 4 to 2 pi. Well, now less than negative 1 is what? All those places where this 0 to 2 pi which we made the range or the interval combined, if it is not greater than negative 1, that is, it is less than negative 1. See, 0 to 3 pi by 4, it is plus, it is increasing. 7 pi by 4 to 2 pi, it is increasing. When it will be negative? It will be between 3 pi by 4 and 7 pi by 4. So when tan x is greater than minus 1, it's the whole union, and when it is less than minus 1, decreasing, is 3 pi by 4 to 7 pi by 4. Now just see how we have solved it, and this is the solution reference for you, because it will be very easy if you make the line, make the number line, show it to the examiner that what do you know, how you have solved this question. Next one is fx is equal to e raised to x is increasing on r. You have to show that this will always be increasing in R. This will go up always. It is not coming down. So increasing on R is real number. Real number means any number possible. So fx is equal to e raised to x. When you differentiate this will be e raised to x, and differentiation of 2x will be 2. So 2 e raised to x. So minus infinity to infinite you have to go. And as I'm saying, that this will always be positive when you take this as greater than 0, because e value is 2.714 something. This is an approximate value of e. 2 is already positive. So whatever you put at x, any negative value or any positive value, you can put any value. You just show me any value, you will see that it will always be positive. Just take x equals to minus 1 and x equals to 1. So e raised to x, what it will be in e raised minus 2. E raised to a positive 1. So 1 by e square, e square. E is a constant number. So it will always be positive. And you are squaring it also. The good thing is you are squaring it also. So there is no problem here at all. Always it will be positive, because e is a constant number and it will always be greater than 0. It will never be negative. So once the value, that is f dash x, is always greater than 0 in all the real number, this range. So 2 e raised 2x greater than 0. I explained you why it is always greater than 0. E raised to x will always be greater than 0 if you divide both sides by 2 in the real number. That is why it is increasing on r. So just see how we have to write. Whatever I have explained is being printed here. Show that e raised 1 by x not equal to 0 is a decreasing function for x, all x not equal to 0. So this what they have given, all x not equal to 0 or whichever thing, this has just been given because x, if it is 0, 1 by 0 will be infinite. E raised to the power infinite will be infinite because e is a constant number. That is why they have given x not equal to 0. But e raised 1 by x will always be decreasing. So just find out f dash x. E raised 1 by x. Differentiation of anything to the e raised to something will be always e raised to something. So e raised 1 by x if it is a variable. Now differentiation of 1 by x also has to be done. That is negative 1 by x squared. So what do you get? Minus 1 by x square and e raised 1 by x. So you have e raised 1 by x and this minus 1 by x square. So you have a negative here. That is, you have a negative sign. So we have to explain that other things will always be positive. So e raised 1 by x, and in the previous discussion also I told you e is a constant number. So whatever you put in x except a 0, it will always be constant value. That is positive constant value. So there will be no negative at all that you can get from e raised 1 by x other than 0, put anything. How about x square? You put minus or plus. It will always be, square will always be positive, plus. When everything is positive, what does it mean? The numerator denominator is both positive in any case, but there is a negative outside. So the result will be negative always. So it will be, if you say f dash x, it is always negative. So it will always be decreasing. Any function which in any case is going to come as negative, that is, it is decreasing all. So how are we going to solve it? So this is the result which you have just seen. Show that the function fx log base ax. Now in initial discussion, various points where this log has come, I have tried to explain what this log is, because one thing is log base ax, we call it as ln x, natural log, and anything which has base, log has base, log base ax. So log base ax means, it just means a raised to the power y equals to x. It's just that only. If you have problem in finding the log, just take this a raised y equals to x. So when we have differentiation log ax, you can take the natural log, make this into natural log. So log x divided by log a, base can be e. So log base ax can be made like this. Now differentiation of this will be what? See, log a is already, in the denominator is already constant. So we have to just differentiate log x. Log x will be 1 by x. And that is the definition of this differentiation also. It will be 1 by x log x. The base is e. Now when you find out that between 0 and 1, if a is there, and if it is x greater than 0, it's like a stick which generally the elderly people use. So if it is between a is between 0 and 1 and x is greater than 0, then this always be decreasing. You see, this is the graph also, it is decreasing at this point. So with the graph it is quite clear, and with the result also, it is 1 by x log x. Anything which x greater than 0, a is between 0 and 1, f dash x will always be decreasing when x is greater than 0, because you know that a is between 0 and 1. If it is greater than 1, a is greater than 1, then it will be increasing. So whatever I have told you, you have to explain it like this. It has no more explanation. The explanation which I gave is enough, but you have to write it. It is not written here, but the explanation has to be written, because it is simply 1 by x log a will always be less than 0. Show that the function fx is equal to sin x is increasing on 0 to pi by 2 and decreasing on pi by 2 to pi. That is 0 to 90 degree it is increasing, and 90 degree to 180 degree it is decreasing, and neither increasing nor decreasing in 0 to pi. So 0 to pi is 0 to 180 degree. So increasing, decreasing. So the second part I'll give the answer first. See, if there is certain interval that is 0 to 180 degree, and at some point the function is increasing and at some point function is decreasing in this interval 0 to 180 degree, then you can say it is neither, the function is neither increasing or decreasing in this interval 0 to 180 degree or 0 to pi. That is very clear. But there may be some parts where it is only increasing, there may be some parts it's always decreasing. So you are not increasing in this range 0 to 180 degree, you are not decreasing, basically you are on the top or you are on the plane. So now this explanation which I gave, why increasing or why it is neither increasing nor decreasing, this will come when we say it is strictly increasing in 0 to pi by 2 and strictly decreasing at pi by 2 to pi. That is 0 to 180 degree has two intervals, 0 to 90 degree and 90 degree to 180 degree. Isn't it? Okay. So we will just take one by one part and show that it is increasing and decreasing. Fx is equal to sin x, but we have to show that first of all the differentiation has to be taken. Sin x will be cos x, and this f dash x has to be greater than 0 or less than 0. And cos x is equal to 0 is the critical point. But at what point cos x equal to 0? At pi by 2. So this is the critical point, and we already know that below it and above it, it is going to be increase or decrease. So f dash x greater than 0 is increasing, f dash x less than 0, it is decreasing. So f dash x is basically cos x. Cos x is greater than 0. What does it mean? Cos x is greater than 0. We are talking about add sugar to coffee. So cos x greater than 0, where cos x will be positive. Cos x will be positive because cos x will always give you the result -1 to 1. Cos x -1 to 1. So from if it is greater than 0, so we are talking about 0 to 1 interval. This is not the number line. I'm just trying to show you what I mean, that the cos x range is always -1 to 1. So if it is greater than 0, we are talking about the range between 0 and 1. So what are the theta value for which 1 and 0 will come? Because cos 0 is 1 and cos by 2, pi by 2, I'm just crossing it because it is not a number line. Just to explain you that this 1, 0, minus 1 is the range. At what value of pi or theta or angle this is going to come. So 0 to 1 will come only when we are talking about, see, pi by 2 to 0. So 0 cos pi by 2 is 0. So the angle will be pi by 2. In order to get 1, you will have to have an angle as 0. So this is 0 to pi by 2. Cos x is greater than 0 in 0 to pi by 2. How about decreasing? Same thing, f dash x less than 0, that is cos x less than 0. Cos x less than 0 means again you are talking about the range which is -1 to 0. And -1 will come when this 0 will come when, what will be the angle when cos is added to that angle? The cos pi by 2 is 0 and cos pi is -1. So pi to pi by 2, or you can say pi by 2 to pi, it is going to be less than 0. Now coming to the second part. See, 0 to pi by 2 it is increasing, and the whole interval 0 to pi has two intervals. In one interval it is increasing, we have shown it. In other interval it is decreasing. So in the whole interval of 0 to pi it is neither increasing nor decreasing, because sometime it is increasing, sometime it is decreasing. So let me show you what I have explained, and this is what you have to give. And I would urge you to make the diagrams and add sugar to coffee to make it more stronger, your argument. Show that fx is equals log sin x is increasing in 0 to pi by 2 and decreasing on pi by 2 to pi. Again 0 to 90 degree and 90 degree to 180 degree we are talking about. So again I am making a number line. I am not making the actual number line. I am just trying to show that this is 0, this is pi by 2, this is pi. Okay, pi is basically 3.14, you know that. So we have 0 and 90 degree and 180 degree. I have just made the number line to show you that we are talking about this interval, 0 to 90 degree and 90 degree to 180 degree. So you have to show that at one point it is increasing, at first interval, second interval it is decreasing. So what is the ninja technique? F dash x differentiated log sin x. So sin x, differentiation of log sin x is 1 by sin x. Sin x differentiation will be cos x, it will be cot x. Cos x by sin x is cot x. Now put it here. See, add sugar to coffee. Now this is tan. Tan and cot, they are brothers. They are always similar. So at the first quadrant and third quadrant, the cot x is going to be positive. In the second quadrant and the fourth quadrant, the tan x or cot x is going to be negative. So f dash x greater than 0, it is for increasing. So cot x should be greater than 0. That is, we can call it as tan x greater than 0, right? So this tan x greater than 0, because cot and tan has just are the reciprocal. So tan 0 is 0, you already know that. But we are not talking about angle here. We are talking about the interval. So we know in the trigonometry, 0 to pi by 2, it's always, cot x will always be greater than 0 in the 0 to pi by 2, because this is the first quadrant I'm talking about. And in the second quadrant, what it will be? Because in the second quadrant, this cot is going to be negative. So f dash x less than 0 means cot x should be less than 0. When cot x is less than 0, we are talking about which quadrant? This is pi by 2 and pi. So between pi by 2 and pi, it is going to be negative. So cot x greater than 0 in 0 to pi by 2 and cot x less than 0 in pi by 2 to pi. So x will belong to pi by 2 to pi. So this cot x is less than 0. So this is how the positive and negative will come. And this is where we can say that it is increasing in 0 to pi by 2 and decreasing in pi by 2 to pi. So this is the whole explanation here. This diagram, you have to make it. Now let me show you how you are going to write it. Whichever explanation I have given, you have to write it, because this is the first quadrant, this is the second quadrant we are talking about. We know what happens in the different quadrants. Now show that fx equals to x minus sin x is increasing for all x belongs to R. So we have some trigonometry involved in here. So I'll show you two solutions and I'll explain one solution. That is, there will be 3 solutions in all, and the logic will remain the same. What do we have? Fx is equal to x minus sin x we have. The first thing we do is the differentiation. F dash x, 1 minus sin x will be cos x. So 1 minus cos x is the differentiation. Now this 1 minus cos x should be greater than 0. That is, if it is greater than 0, it will always be increasing function. And this x belongs to R we are talking about. So we are talking about the real numbers, all possible numbers, positive, negative, decimal, any number. Now see here, I'm writing it like this. See, cos x range and sin x range is between -1 and 1. The domain is anything. You can put any number in the domain. But whenever we put anything in the x, the cos x will only fall between -1 and 1. It will only be between -1 and 1. So -1 to 1. This is the thing. This is the criteria we are going to use. So this is, you know that cos 0 is 1 and cos pi by 2 is 0. If you remember this thing, these questions are easier to solve. So remembering the graph of cos x or the range of cos x or sin x will immensely help in solving the question. So if you think about it more, just show that 1 minus cos x is greater than 0 with these inputs. So cos x is between what? -1 and 1. As I said, it will always be between -1 and 1. Now multiply both sides by -1. When you multiply both sides by -1, what do you get? The angles will change or the inequality will change. So less than will be greater than will be less than. So when you multiply both sides by -1, what will happen? This will be negative will be positive. It will be 1 plus 1. This is going to be negative cos x, but the inequality sign is going to change. This also is going to change. So we have minus cos x. Here 1 minus 1 is -1. Now just add a 1 to all of the numbers. Just plus 1. Here also plus 1. Here also plus 1. So what do you get here? This is 2. 1 minus cos x is, and this is going to be 0. So forget about the left part. Just concentrate on the right part, that is 1 minus cos x greater than 0. I told you earlier, if 1 minus cos x or f dash x is greater than 0, that is going to be increasing in all the real numbers. This is the answer. Now let me show you the solution here. So you need to solve it like this, write it like this. So this is the first solution, this is the second solution. So different ways to do the same question, different ways to write it also. Show that this is an increasing function for all x belongs to R. So we have done question like this, but specifically we just have to show that it is increasing function on this real number. So we'll just differentiate this. F dash x is going to be, x cube is going to be 3x square. This 15 into 2 is 30. So you have 30. X 75 will remain like that. And this minus 50 will be in the differentiation, it will be 0. So if you take 3 common, what are you going to get? X square minus 10x plus it's 25. So now you have x square minus 10x plus 25. And by our previous experience, we know that what it is going to be. X minus 5 whole square is going to be what? A square plus b square minus 2ab. And what is this? This is exactly equal to what we got. So just replace it by x minus 5 whole square. Now you tell me, anything you put x here, because it is square, it is always be positive. 3 is always already positive. So it will always be increasing. Now let me show you those who can understand by example. So I'm giving you an example also here. So we have this 3 has no problem. It is a constant. It is positive. So we don't have to worry about 3. How about the x minus 5 whole square? So I'm putting 1 at one time, -1 at one time. I'm just wanted to show you that it's always be positive. So this is 16, this is -6 whole square, it will be 36. So whatever you do, the square will make the negative as positive. So this term 3x minus 5 whole square will always be positive in any case. That is why this is an increasing function for all x which is belonging to R. I hope you got the idea. Negative square will always be positive in any case, whichever way you want. Now let me show you the solution here. This is the reference which you can follow. Just write these and explain what I have explained. Show that fx equals cos square x is a decreasing function on 0 to pi by 2. So let us differentiate it first. F dash x is going to be, cos square x will be 2 cos x. Differentiation of cos x will be minus sin x. So this is going to be minus 2 sin x cos x. So 2 sin x cos x will be sin 2x. So we have minus sin 2x. So we have to show that it is decreasing. So if you are able to show that this in this interval 0 to pi by 2, it is always negative. That is, it is less than 0. So I am showing it less than 0. This angle will be less than 0. So you have to prove that sin 2x is going to be positive because the negative is already there with us. So we just need to show that sin 2x is positive. So we have x between 0 and pi by 2. Just multiply everything by 2. Everywhere by 2. So 2 into 0, 2 into x, 2 into pi by 2, it is 0. This is 2x, this is going to be pi. 2x between 0 and pi. Now come to add sugar to coffee. And when you see this add sugar to coffee, this 2x. Now when you take this sign, see where the problem will arise if I take sign on both the sides. it will be sine 0, this also sine pi, and you know that sine n pi is going to be 0. So the sine 2x will be between 0 and 0. So that will be a problem. So you don't go like this. I'm just cancelling this out. I'm just showing you that if you go ahead with this kind of solution, you will not be you will be going nowhere. So this is the way. See, everywhere in the first quadrant it is positive, everywhere in the second quadrant it is positive. So it is positive between 0 and pi. Sine will be positive between 0 and pi. This is established from trigonometry also. So if I take the sine of any angle between 0 and pi, it's always going to be greater than 0. That's what I told. And that's what you know from previous experiences. Alrighty. Now what do you see here? We have negative sine 2x. So we have a negative here. So the inequality will change. Multiply both sides by negative here. So sine 2x is minus sine 2x will always be less than 0. And minus sine 2x is what? It is fx. It is the function f dash x, sorry. So f dash x will always be less than 0. When you have differential which is less than 0, that means this function is decreasing function in the given domain. Now let us see the reference solution that you have to follow. You have to apply the logic here and just make the diagram also. It puts lot of plus to your solution. Always diagram is very much appreciated by the examiner. Show that fx equals sine x is an increasing function in negative pi by 2 to pi by 2. So fx is equal to sine x. F dash x will be what? Sine x will be cos x. Now in negative pi by 2 and pi by 2, please remember, pi by 2 is 90, negative pi by 2 is also 90, but on the other side. So when we can show f dash x is greater than 0, that is cos x is always greater than 0, it will be increasing function. So negative pi by 2 to pi by 2, you already know it is always increasing, always positive. Now the second explanation which I can give is this is pi by 2, so this is negative pi by 2. Why I am calling it as negative pi by 2? Because cos plus pi plus pi by 2 is negative pi cos pi by 2. You already know that. So 3 pi by 2 is nothing but pi plus pi by 2. When you take the cos, it will be minus of cos pi by 2, which is minus of whatever cos pi by 2 comes. So this negative pi by 2 to pi by 2. So we are starting from here and we are reaching till here. This is the whole area we are talking about. So add sugar to coffee. Where do you see the cos is positive? In the first quadrant and in the fourth quadrant. And in the negative pi by 2 and pi by 2 is also talking about the first quadrant in fourth quadrant. That is why this cos is always greater than 0. That is, it is increasing function. Now let me show you the exact thing which you have to write. So this is just 3 lines you have to write, but the explanation I gave is important. Show that fx equals to cos x is a decreasing function on 0 to pi, increasing in negative pi by pi to 0 and neither increasing or decreasing in negative pi to pi. What does that mean? Let us come to the second part actually. Third part actually. So I'm not making the number line. I'm just trying to show you what they want. They are saying that we have negative pi and pi. There's a 0 in between. They are asking that this function cos x is going to decrease in 0 to pi. It is going to increase in negative pi to 0 and between negative pi to pi. If a function is increasing also and decreasing also in a given range, that means that function is neither increasing nor decreasing. That is, sometimes it is increasing, sometimes it is decreasing, or vice versa. That means if we are able to show decreasing and increasing in the separate interval, then in the combined interval, it is not going to increase or decrease either. So let us start with our basic things. Fx equals to cos x. F dash x is going to be cos x will be minus sin x. This is minus sin x. Now just show that in between 0 and pi and negative pi to 0. So this is add sugar to coffee. We are talking about. So what does negative pi means? That is important. Negative pi means it's if you place say a mirror in between 0, then pi and negative pi are mirror images. So cos x differentiation is negative sin x. Sin x is positive where? Tell me, where is it positive? It is positive in the first quadrant here and the second quadrant here. So 0 to pi it is going to be positive. We already know that by our trigonometry. Add sugar to coffee, add a means all, s means sign. So between 0 and pi it is going to be always increasing. It is always positive. But you have a negative sin x. When you have negative sin x, the things will change. That is, in 0 to pi, sin x was increasing, but negative sin x is going to be decreasing. 0 to pi. So this is decreasing. Minus sin x less than 0 is decreasing in the given 0 to pi interval. How about negative pi to 0? What is negative pi to 0? If you start from this one and come here, see this is basically when you come again and again, you take a round, it will be pi, 2 pi, 3 pi, 4 pi like this. So sometimes when you take this angle, sometimes it will be positive, sometimes it will be negative because sine ranges from negative 1 to 1. That is why you have negative pi and pi. So sine x is less than 0, negative pi to 0, as I just told you, and you multiply both sides by negative, it's going to be greater than 0. So f dash x should be greater than 0. So here it is going to be increasing. Minus pi to 0, it is going to decrease. But since it is negative sine x, it's going to be increasing in this negative pi to 0. And what about the third part, which I answered previously? That is in the negative pi to pi whole interval. Sometimes it is increasing, sometimes it is decreasing. And that clearly shows that it is neither increasing nor decreasing. Please remember, in the third and fourth quadrant, sign is always negative. First and second quadrant, sign is always positive. That is why when you put negative in front, it will be inverted. So this increasing and decreasing and increasing has changed because of the minus sin x. F dash x was minus sin. Now this is the explanation which I gave, and I would encourage you to draw the diagram that will make it more fruitful. Show that fx equals to tan x is increasing function on negative pi by 2 to pi by 2. So in order to show increasing, the differentiation should be greater than 0 in this negative pi by 2 to pi by 2. This is the first thing. I am saying that tan x is there. We will just differentiate it. So differentiation of tan x is sec square x. So this sec square x, when you're talking about negative pi by 2 to pi by 2, first you have to see sec x or cos x where it is positive and negative. So add sugar to coffee again. I am talking about sec x. It is almost this sign in sine or in the negative and positive terms. Sec and cos are almost equal. Actually 1 by cos x is sec x, but negative if it comes, it doesn't have any difference. So cos is positive in the first quadrant and the fourth quadrant. This is first quadrant and fourth quadrant. So this is sec square x. You see sec x should be greater than 0. In which quadrant? Minus pi by 2, pi by 2. I told you this is pi by 2, this is negative pi by 2. So minus pi by 2 to pi by 2 or pi by 2 to minus pi by 2, it is going to be greater than 0. You already know that because I'm talking about cos x, which is actually the inversion of sec x. So minus pi by 2 to pi by 2 is the given interval. In this interval, if we apply the trigonometry, add sugar to coffee scenario, it is going to be positive. If you square both sides, it's going to be sec square x, which is greater than 0. So you have f dash x, sec square x, which is greater than 0. So f dash x is greater than 0. That means this function is increasing on this negative pi by 2 to pi by 2. Now I told you, and this is the result which you have to write and use the diagram also. Now this is show that tan inverse of this sin x plus cos x is a decreasing function on the interval pi by 4 and pi by 2. So let me differentiate it first. F dash x, the whole effort in this question is only differentiation. I'm telling you. Tan inverse x differentiation is 1 by 1 plus x square. Whatever is there in x, it will be 1 by 1 plus x square. So what is x in this question? A sin x plus cos x. So 1 by 1 plus sin x plus cos x whole square it will be. And then the differentiation of sin x plus cos x, and sin x plus cos x differentiation is what? Cos x, and then cos x will be minus sin x. So cos x minus sin x divided by 1 plus sin x plus cos x whole square. I am taking the denominator now and I am squaring it. Once this is sin square plus cos square plus 2 sin x cos x. Sin square plus cos square is 1. So 1 plus 2 sin x cos x. 2 sin x cos x can be taken as sin 2x. So it will be 1 plus 1, that is 2 plus sin 2x. So for what we got? Cos x minus sin x divided by 2 plus sin 2x. Okay. Now we have to take this numerator and denominator separately because the pi by 4 and pi by 2 is the given interval where things can vary. Combination of sin x and cos x is given. So this pi by 4 and x in between we are talking. So the pi by 4 is nothing but 45 degree, pi by 2 is 90 degree. So multiply both sides by 2, you are going to get pi by 2 is less than 2x less than pi. So 2x is between pi by 2 and pi. And now you see, add sugar to coffee. If I take, this is pi by 2 and pi. Between pi and pi by 2, sign will always be positive. See, I am talking about pi by 2 and pi, that is 90 degree and 180 degree. In between this, by this diagram, you know sin 2x will always be greater than 0. Now add 2 to both the sides. Then also it will be greater than 0. 2 plus sin 2x will be greater than 0. So 2 sin 2x plus 2 will be greater than 2. So if it is greater than 2, it is already greater than 0. So 2 plus sin 2x will always be greater than 0. This is the denominator. So we have established one thing. The denominator 2 plus sin 2x will be greater than 0. How about the numerator? Cos x minus sin x we are talking about. Cos x minus sin x. Okay. Now we have to go to the detail of pi by 4 and pi by 2. I am giving you a very naive example. Sin pi by 4 is what? Cos pi by 4 is what? This is sin pi by 4, cos pi by 4, it is 1 by root 2, 1 by root 2. You know that it is the cos 45 degree and sin 45 degree. How about sin pi by 2 and cos pi by 2? Sin pi by 2 is 1 and cos pi by 2 is 0. So just make a line and just understand that where the sin is sin greater than or less than cos. in this particular pi by 4 and pi by 2 interval. Now this 1 by root 2 is here, 0 and 1 I have made. Now sin pi by 4 is 1 by root 2 and sin pi by 2 is 1. So this is the area where sin is there. What are the values which can come when you take the cos of pi by 4 and pi by 2? It is between 0 and 1 by root 2. So now you see here sin x is greater than cos x. So you can just write it as cos x is less than sin x or sin x is greater than cos x. These both things you understood. Now take this side. Cos x minus sin x is less than 0. So cos x minus sin x is less than 0. So the numerator is less than 0 and the denominator is greater than 0. That means when you combine numerator and denominator, it will always be negative. I am saying a by b. A is less than 0, b is greater than 0. That means what? It will be less than 0. The whole quotient or the p by q form is going to be less than 0. That is why this f dash x is less than 0. So in this particular interval, pi by 4 and pi by 2, f dash x is less than 0. And in between this pi by 4 and pi by 2, when it is less than 0, it is a decreasing function in this interval. So there are two things which you have to tell. You have to do the numerator and denominator separately, keeping in mind this pi by 4 and pi by 2. Now this is how you're going to do it. These are the steps you're going to follow. And first I told you about the differentiation, then sin 2x, 2 plus sin 2x is greater than 0. Then I told you cos x minus sin x, and that is going to be less than 0. That's how the whole comes to be less than 0 in this particular interval pi by 4 and pi by 2. The interval plays a very important role here. Show that the function fx is equal to sin 2x plus pi by 4 is decreasing on 3 pi by 8 and 5 pi by 8. This is the interval being given. So what are we going to do? First thing is to differentiate. Increasing, decreasing means differentiation. The first thing has to be differentiate. So sin theta differentiation is cos theta. That is cos 2x plus pi by 4. Then we have to differentiate 2x plus pi by 4. So it will be 2. Now this one, this f dash x should be less than 0. In order for this to be decreasing, it has to be less than 0. And the x is in between 3 pi by 8 and 5 pi by 8. So let us write this. X is between 3 pi by 8 and 5 pi by 8. Now try making it 2x plus pi by 4. For that we have to multiply both sides by 2. I'm multiplying both sides by 2. What do you get? This 2 4s 8. So 2 4s 8. You get 3 pi by 4 on the left and 5 pi by 4 on the right. So now 2x is in between 3 pi by 4 and 5 pi by 4. Next is to add pi by 4 because we need this angle, so that we can go ahead and define the decrement. So I'm now adding pi by 4 on both the sides. Since the base is same, so just add the numerators. 3 pi plus pi is 4 pi. We have 4 pi by 4. Pi gets cancelled. So you have a pi only. 2x plus pi by 4. Now 5 plus pi is 6 pi. 6 pi by 4 is 3 pi by 2. So this becomes 6 pi by 4. You can just cancel this with 2. 3 pi by 2. Pi is in between 3 pi by 2. Now you don't have to worry about anything because if you are aware of trigonometry and you can explain through trigonometry that the angle between pi and 3 pi by 2. So when we say add sugar to coffee, this pi and 3 pi by 2 means 180 degree and 270 degree. So we have the angle between pi and 3 pi by 2 which is 180 degree and 270 degree. So now tan is positive here. Other things, other angles, they are negative. So cos 2x plus pi by 4 between pi and 3 pi by 2, as I suggested here, and this is the established fact, that is less than 0. Multiply both sides by 2. It doesn't matter on right because multiplication with 0 will give you 0 only. So whole expression that we found is less than 0. And that we wanted to prove. F dash x is, if it is less than 0, then the function is decreasing. So this is decreasing in this interval. Okay. Now I got to show you the information which you have to write when this question comes, or the content. So all these you have to write for all x and c. I give always the logic. The written material is what you have to complete. So show that the function. The question of this sort of tan inverse we have already taken, if you remember. Now this is decreasing on 0 to pi by 4 and increasing in pi by 4 to pi by 2. So there is a slight change in this question because we are talking about pi by 4 is this one. Pi by 4 is simply 45 degree. So 0 to pi by 4 is this one, and pi by 4 to pi by 2 is the above one. That is pi by 4 to pi by 2 is the other half of the first quadrant. So add sugar to coffee we are going to use. So we will differentiate it first. So cot inverse x differentiation is negative 1 by 1 plus x square. What does that mean? We have sin x plus cos x in place of x in this case. So when we take the differentiation, it will be just negative 1 by 1 plus sin x plus cos x whole square. So we have this sin x plus cos x whole square. We have sin x plus cos x differentiation as cos x minus sin x. So numerator denominator we have already differentiated now. Now I am opening the denominator. So sin plus cos whole square is sin square plus cos square plus 2 sin x cos x. Now this sin square cos square is 1, means sin square theta plus cos square theta is equal to 1. And then we have this 1 plus 1. You can write 2 sin cos as sin 2x, or you can just keep it like 2 sin cos x also. Now this is negative in the numerator, so I'm just swapping cos and sin so that we can eliminate this negative sign. Now I'm writing whole sin x minus cos x divided by, this is 2 plus 2 sin x cos x. Now this one, either you can go for numerator and denominator separately, that you can show that whether it is increasing or decreasing. I'm taking this 2 outside. So this 2 I have taken outside in the denominator. So it has to be decreasing on 0 to pi by 4, that we have to show. So this has to be less than 0. F dash x should be less than 0. And it should be increasing in pi by 4 to pi by 2. There is a slight mistake in the question which is written here. I'll just change it just now. So first we'll show it decreasing in 0 to pi by 4. So I'm writing it short because it will take time. So sin and cos s and c. F dash x should be less than 0 in order to show that it is decreasing in 0 to pi by 4. That is the interval being given, the first interval. So both sides multiply by 2 1 plus sin cos. That is, if you multiply both sides by twice of 1 plus sin cos, this gets cancelled, and on the right also it will be multiplied by 0, so only sin minus cos should be less than 0, or sin should be less than cos. If you divide both sides by cos theta, it will be 10x less than 1. Now 10x less than 1 is between 0 and pi by 4. We already know tan 0 is 0 and tan pi by 4 is 1 by root 2. So it is less than 1. 0 to pi by 4, it is less than 1. You already know that 1 by root 2 is what. So sin x is less than cos x. We divided both sides by cos x. And in the previous question of this sort, exactly like this sort, I told you, find out the value of sin 0 and sin pi by 4. Find out the value of cos 0 and cos pi by 4. Show it on the number line and you'll see that actually this cos is higher than sin in this range, 0 to pi by 4. So between 0 and pi by 4, if you just take angle also, so tan 0 is 0, tan pi by 4 is 1. So you're talking about anything which is less than 1. In number line also you can show that. But we already know that it is established fact between 0 and pi by 4, tan x is less than 1. How about f dash x greater than 0? So sin minus cos divided by twice 1 plus sin cos. This should be greater than 0. So greater than 0 means multiply both sides by 1 plus sin x. Twice 1 plus sin x will be better, which we did in the first part also. So when you multiply this, on the right it is multiplied by 0, so it will remain like that, and here it will all be cancelled. So sin minus cos x should be greater than 0. That is, sin x should be greater than cos x. Again, as I said, it is the interval is a slight mistake in the question, so it is pi by 4 to pi by 2. So when you divide both sides by cos, it should be tan x greater than 1. So x is between pi by 4 and pi by 2. It is already given in the interval. So when it is given in the interval, you know tan pi by 4 is what? It's tan pi by 4 is 1, and tan pi by 2 is infinite. So actually it is greater than 1. So I am saying this is not 0 to pi by 4. It is actually pi by 4 to pi by 2. So when you take x between pi by 4 and pi by 2 and you want to ask for the angle, tan by 4 pi by 4 is 1 and tan pi by 2 is infinite. So it is actually greater than 1. 1 to infinity is greater than 1 only. In the previous part we said 10x is less than 1. That is, it is 0 to 1 in this 0 to pi by 4. Here pi by 4 to pi by 2 is higher than 1. So f dash x is greater than 0. So it is greater than 0. It is increasing in this interval. So how are we going to solve this? This is the whole procedure. You just add here, because I told you there is a slight mistake in the question which is being printed here. It is increasing in between pi by 4 and pi by 2. Alright, just write decreasing and change the interval and write it here. I'm writing it here. I'm just changing what I initially intended. I told you that there is a slight change here, pi by 4 to pi by 2. Show that fx is equal to x minus 1 e raised x plus 1 is an increasing function for all x greater than 0. Just find out f dash x. When you take f dash x, we'll follow the product rule. Differentiation of 1 is going to be 0. So just eliminate that. We have x minus 1 e raised x. So x minus 1 e raised x, then e raised x minus 1 differentiation will be 1 only. So when you take e raised x common, it will be x minus 1 plus 1. So 1 gets cancelled. You will get x e raised x. So the whole idea is to show that x into e raised x should be increasing or should be greater than 0 when x is greater than 0. When x is greater than 0, x will be positive. When e raised x is positive, again e raised x is positive, that is e is a constant number which is 2.714, so like that. And if you take any positive number over it, means as the power, it's going to give you positive only. So x raised ex should always be greater than 0. So f dash x is greater than 0. So this function is increasing for all x which is greater than 0. So the things you have to write here is like this, and this for all and all these mathematical symbols you need to use so that you complete the answer and explain it to the examiner. Show that the function x square minus x plus 1 is neither increasing nor decreasing in 0 to 1. Now just concentrate on 0 to 1. So if we are able to show between 0 to 1, it is increasing somewhere, it is decreasing, we are able to show neither increasing or not decreasing. So first is f dash x, it is 2x minus 1. So if it is increasing, it should be for f dash x greater than 0 and less than 0 if it is decreasing. So 2x minus 1 is greater than 0, 2x minus 1 should be less than 0. 2x minus 1 greater than 0 means 2x should be greater than 1. Here 2x should be less than 1. Here x should be greater than half. Here x should be less than half. Greater than half means, so just in between 0 and 1, what you are going to get? So it is increasing if it is higher than half. And you just have to concentrate between 0 and 1. So half to 1 it is positive, it is increasing. X less than half means you are talking about this part where it is decreasing. So in between 0 and 1, one time it is decreasing, one time it is increasing. That means it is neither increasing nor decreasing. That is the conclusion we can draw. So here you see, I'll just show you the way you need to go about and write all those stuff which I explained. And case 1, case 2 will be better, and showing it on the number line. The diagram is always beneficial for you to make the examiner understand that you know everything and you have solved it with all your intellect might. Show that the function, this one, is an increasing function for all x belongs to R. Now first one is differentiation. I already told you increasing, decreasing means you have to differentiate. X raised 9 is 9x8. First and 4 is 28. 28x6. X raised 6, and this is going to be 0. Now the only thing which you need to understand or to explain to your examiner, that anything with power 2 or anything with the power even, whether it is negative, whether it is positive, it will always be positive. So the square will make negative to positive. Positive is already positive. So even if it is negative and the power is even, it will be positive always. Okay, so x raised 6 and x raised 8, they are also greater than or equal to 0. Or you can write it as x squared to the power 4, 28 x squared to the power 3. It doesn't matter it is power 4 or 3, it is already squared. Squared will always give you positive value. So whatever you do, any number you place from real number, it is always be greater than 0. So what I told you, this is what you have to follow. There are just few lines you have to write. The whole idea is that even power of x will always be positive because it will make all the negatives positive, greater than 0. Next one is also like that. Prove that the function, this one, is increasing on R. So f dash x will be equal to 3x square minus 12x plus 12, and 18 will be 0. So when we take f dash x, it is going to be, I'm taking 3 as common, x square minus 4x plus 4. Now you already know x square minus 4x plus 4 is x minus 2 whole square. You already know that from algebra. A square minus b square a square plus b square minus 2ab, that is the expansion of a minus b whole square. So it is always 3 is a constant. It is already positive. X minus 2 whole square, as I told you, anything with the power 2 or even power will always be positive. So when you multiply positive with positive, it is going to be positive only. So when it is positive, that means f dash x is greater than 0, or it can even be equal to 0. But it is increasing. Now how you are going to write about it? 3 greater than 0, it is a constant. X minus 2 whole square greater than or equal to 0. So fx is increasing on R. So this is increasing. So in real number, this function indeed is increasing. State when function fx is set to be increasing on interval a, b. Test whether this function is increasing on the interval 4, 6. So the definition is simple. Fx is set to be increasing in the interval a and b if f dash x. The differentiation has to be taken. Without differentiation, you won't be able to tell it is increasing or decreasing. So the f dash x in this a-b interval, it has to be greater than 0. In this whole interval, it's not that it is increasing somewhere, it is decreasing somewhere between a and b. It has to be increasing always between a and b. So we'll just try and explain this definition with this question, the second part. So we have to test. X square minus cx plus 3, 6x plus 3 in 4 to 6. So I'm differentiating it. It's 2x minus 6. Now 2x minus 6, if it has to be greater than 0, I'm finding f4, f-4 and f-6. So there are two things which simultaneously I'm doing. f-4 is 2 into 4 minus 6. f-6 is 2 into 6 minus 6. That is 8 minus 6, 2. 12 minus 6 is 6. So what do you get? You get the value 2 and 6. Here also 2 is greater than 0, 6 is greater than 0. And there is no point in between where you get f-x less than 0. Even if you put anything 5, 4.5 or say 5.5, you will always be getting increment. So let us see the reference solution here, and this solution has to be, see, the first part is the explanation of the definition, and second is the implementation of that definition. So this is f-x greater than 0 is the whole idea, the key idea of this question. Show that fx is equal to sin x minus cos x is an increasing function in negative pi by 4 and pi by 4. Need to understand the negative part of anything is the mirror image in the trigonometry. So that is we are going to take in the next discussion just now. But first let us differentiate this cos x plus sin x. When you differentiate this, that is f-x, we have cos x plus sin x, because sin x is cos x is minus sin x. When you see minus pi by 4 and pi by 4, if cos x plus sin x is increasing in this interval, it is increasing function. So f-x is greater than 0, that we have to show. X is between negative pi by 4 and pi by 4, that is already given in the question. Now add sugar to coffee, just see here, add sugar to coffee. Now where pi by 4 is what? It's 45 degree. Minus pi by 4 is what? It's minus 45 degree. So I'm just taking cos x common here. It will be 1 plus tan x. So either you show that cos x is positive here and sin x is positive here. If you can show that, so that won't be possible because sin x in the third quadrant is negative actually. So you have to take those things which is positive in this range. If you take cos on both the sides, here cos minus theta is plus cos theta, sin minus theta, tan minus theta is minus tan theta or minus sin theta. But cos negative theta is plus cos theta. So what do you get? This is 1 by root 2, 1 by root 2. But you know that you cannot go forward with this. What does it mean? X is between 1 by root 2 and 1 by root 2. That doesn't solve anything. So that is the wrong approach. But here, if you see, this is pi by 4 and this is negative pi by 4. So you are talking about anything which is in between this area. So all is positive, cos is positive. Between minus pi by 4 and 0, it is going to be positive. So basically minus pi by 4 and pi by 4, cos is going to be positive. So we change this into cos x into 1 plus tan x. So we already have shown that cos x is greater than 0 in this, through the diagram and through the trigonometry. Now come to the second part, which is 1 plus tan x. If we can show this 1 plus tan x as positive, cos x already is positive. Multiplication of positive will be positive. So it will be an increasing function. So we'll go with 1 plus tan x and try to show that it is in between negative pi by 4 and pi by 4. It is actually positive. So tan x is what? Now minus pi by 4 and you have x, it is pi by 4. Again, same thing I'm taking. There is no other logic, the things are given, you just have to go forward with all your background knowledge. So let us take the tan of all these. So if I take tan, it will be tan x in between. It will be tan negative pi by 4. This will be tan pi by 4. Now tan negative pi by 4, this was not logical. X between 1 by root 2 and 1 by root 2, what does it actually mean? It doesn't mean anything. But when you take tan minus theta is minus tan theta. And tan pi by 4 is what? It's 1. So tan x is between negative 1 and 1. I'm saying when we took tan pi by 4, tan minus theta is minus tan theta. So on the left of tan you got negative 1. On the right of tan you got 1. Tan x between negative 1 and 1. Alright. So just add 1 to all of these. When you add all of these, you'll get 0 here. This 1 plus tan x and less than 2. So what do you see? 1 plus tan x is actually between 0 and 2. And between 0 and 2, that means it is positive. 1 plus tan x starts from 0 and ends with 2 in the interval minus pi by 4 and pi by 4. So this is positive. We already showed cos is positive. 1 plus tan x also is positive. So when we multiply positive, it is going to be positive. So it is greater than 0. So positive multiplication is positive, it is greater than 0. That is f-x is greater than 0. So it is greater than 0 and it is positive. That is what we wanted. And then we showed that actually this is sin x minus cos x is increasing in this interval. Now I got to show you how you are going to go about it, because writing is more important. Whatever you know, you have to put it on the paper. Otherwise, there is no way the examiner would understand that you know all of it. So this question has a slight variation here. People have solved with cortex also, but the logic remains the same. Just go forward with what I have explained you. Show that fx equals to tan inverse x minus x is a decreasing function on R. So we have taken a lot of questions, and by now you know that f dash x, if it is greater than 0, then the function or the fx is increasing, or when it is less than 0 it is decreasing. So in order to prove that it is decreasing function, we have to prove that it is less than 0. We are differentiating it now. Differentiation of tan inverse x is 1 by 1 plus x square. X is 1 only. Let us take the LCM. If there is any problem, just multiply this one. Take care of the sign. Multiply 1 plus x square with 1. It will be negative then. And multiply the denominators and write it here. 1 plus x square into 1. This is the ninja technique to easily solve. So when it cancels, you will find out minus x square by 1 plus x square. So now we have to show that it is decreasing. This is real number. So every real number, any number which can be painted or put on a number line, those numbers fall into the category of real number. It can be integer, it can be decimal, any number. Let us take the x square first. You are already aware that whenever you have negative or positive, the square will always be positive. So x square will always be positive in any case. When you have x square, if you add a 1 with it, it will always be positive, because adding 1 with a positive number will make it positive only. Alright? See, x square will make things positive, and adding certain thing will always make it positive. So x square is positive, 1 plus x square is positive, whole numerator denominator is positive, but you have a negative outside, so it will always be negative. That is f dash x, since this becomes negative in any case, it is less than 0, and when f dash x is less than 0, we say, if you remember in the beginning of this question I told you, if it is less than 0, then it is a decreasing function on R. So this decreasing function, let us see how to write it now, because this is logic and writing is most important. So this is how you are going to write. So this portion we have proved it to be positive, and then you have a negative that will make it as negative, that is less than 0. And when it is less than 0, this function is decreasing on the real number R. Now determine whether fx equals to this one, minus x by 2 plus sin x, is increasing or decreasing on minus pi by 3 and pi by 3. So this pi by 3 is what? Pi by 3, those who are not able to understand, I have the duty, I have this responsibility to let them know also, because most of the people might know, but everyone should know. What is this pi by 3? How to convert this radian into degree? Always this will come. So just multiply it by 180 by pi. So now it will be changed to degrees. So 3 6 are 18, so 60 degree. This is 60 degree. We are talking about 60 degree and minus 60 degree. There is nothing called minus 60 degree, but I'll tell you what, it is just a mirror reflection of pi by 3 on the coordinate axis. So we need to find out whether it is increasing or decreasing. First thing what we'll do, we'll just differentiate. So this f dash x is going to be minus x by 2. This minus 1 by 2 is constant already. So you just have to differentiate x. This is differentiation of x is what? It's going to be 1. Sin x will be cos x. So you have cos x minus 1 by 2. So we'll start with cos x. This is cos x. Now cos x is, this x is between negative pi by 3 and pi by 3. X is in between negative pi by 3 and pi by 3. But if you take cos, let us take the negative part to make you better understand, because plus part will always be the thing which are very default. So now when we take cos on both the sides, cos minus theta is plus cos theta. Cos negative theta is plus cos theta. That is, in sin and tan, sin minus theta is minus sin theta. Tan minus theta is a minus tan theta. But cos negative theta will be positive cos theta. So minus cos pi by 3, this minus will not come here. I am saying it will always be plus. Cos minus theta is plus cos theta. So it will be cos pi by 3, which is going to be half. So cos x is greater than half. When you have x with cos x which is greater than half, what does that mean? What does that mean? Now this half, where to get this half? Because if it is greater than half, there has to be certain thing. So cos half I am taking on the left hand side. It is cos x minus 1 by 2. I have told you already, f dash x is simply cos x minus 1 by 2. Now it is clear. Now if it is greater than 0, the content or the expression of f dash x, if it is greater than 0, then we say that this is an increasing function. So your question will be, this cos minus theta is plus cos theta. I'm not convinced with that. So there is a second explanation. So this question can be solved in multiple ways. Second part I'm saying, add sugar to coffee we are doing. Now this is pi by 3 and negative pi by 3. What is this pi by 3? 60 degree. And what is minus pi by 3? Whenever you have negative with the same one, it is just the mirror opposite or reflection. So this is negative pi by 3. Now you see, in the first quadrant and in the fourth quadrant, cos x is positive. Alright. And what? It is positive. But we got this pi by 3, so we checked it for pi by 3 and it came cos x was greater than half. So cos x greater than half, then we proved cos minus half is greater than 0, and that is the required and necessary condition for the function to be increasing. Alright, in mathematics there can be multiple ways to solve and explain a particular solution. So it's up to you whichever way you like to answer this question. Now the next thing is to show you exactly what you have to write, because logic is very important. I invest my most of the time in explaining you rather than writing it. That is logic is important. Writing you can do if you know the logic. See, if you have knowledge, you can get the job, right? So it's better to have logic. Job you will get. If I tell you the logic, you will write or you will solve the question by yourself, right? So this is the logic which you have to follow. All these mathematical symbols for all this you have to write. Find the intervals in which this fx equals to log 1 plus x minus x by 1 plus x is increasing or decreasing. So this is an important question. Why it is important? Because it has already come in CBSE. It has already come in the examination. In order to take these kind of questions, we need to have multiple mathematical topics in our mind. That is, you need to know log, you need to know differentiation of log. So this is log 1 plus x. What will happen if I put x as minus 1, log 1 minus 1 is 0. How can you define it? So you cannot have x as negative 1. 1 plus x cannot be 0. 1 plus x equal to 0 is the problem. X equals to minus 1 is the problem. So x cannot be minus 1. How about x by x, 1 plus x? 1 plus x cannot be 0. 1 plus x cannot be 0. That means x cannot be 0 because you are adding 1 to x only. 1 plus x is equal to infinity means what? X equals to infinity minus 1. If you subtract anything from infinity, it will be infinity only. If you add anything to infinity, it will be infinity only. So you have log 1 plus x, it is saying negative 1. X by 1 plus x is saying it has to be between negative 1 to infinity. That is, I am telling the domain. The domain is very important. So this particular function is valid only between negative 1 and infinite. Alright, I hope you got the idea. So this 1 plus x cannot be equal to 0, x cannot be equal to minus 1. 1 plus x cannot be 0 in log terms, so it cannot be equal to minus 1. So it has to be higher than minus 1. Higher than minus 1 means minus 1 to infinite. Now I am differentiating. Log 1 plus x differentiation is 1 by 1 plus x. X by 1 plus x differentiation is what? So we'll do it using the equation rule. 1 plus x square here. 1 plus x will be here. A differentiation of x will be 1. Then you take this minus. So this x is there. Differentiation of 1 plus x will be 1 only. So in the numerator you have 1 plus x minus x, x get cancelled, you have 1 by 1 plus x whole square. So you have 1 by 1 plus x whole square. Next thing you can do is to take the LCM and you can solve it, and this is how you can go about it. But I always have a better idea for you. So better, rather than going for this cumbersome method, we know that 1 by 1 plus x is common. Why not to take 1 by 1 plus x common? So if you take 1 by 1 plus x common, you will get inside what? 1 minus 1 by 1 plus x square. So 1 plus x square was there, so 1 plus x already taken, only 1 plus x is there. So now cross multiply, 1 plus x minus 1 by 1 plus x. So what do you get? X by 1 plus x. So solving this by my method, it will easily make you feel easy to solve it. So x by 1 plus x square is there. Now you just see, if you want to show it increasing, it has to be greater than 0. If you want to show it decreasing, it has to be less than 0. This is very much in your mind. But please remember, the domain is only from negative 1 to infinity. X cannot be negative 1. It is always higher than negative 1. So we went up to infinite. That is, minus 1 to infinity was the domain. So this 1 plus x whole square will always be positive. So that means x should be greater than 0. That is, I am saying in between minus 1 and infinity, f dash x is greater than 0 when x is greater than 0. But we have the domain minus 1 to infinity. We have x greater than 0 now. So you cannot take this point. It is greater than 0. So you will take only things which are beyond 0 up till infinity. So this will give you 0 to infinite. This will not be taken. This cannot be taken. 0 to infinite is what f dash x greater than 0 gives you. So f dash x greater than 0, that means you are talking about 0 to infinite. This is the answer. Alright. But what about the less than 1? Decreasing. We have to tell the interval also of less than. Now we have come to the decreasing one. So f dash x should be less than 0. So x plus 1 by x whole square should be less than 0. Now this 1 plus x whole square, that is anything with square, cannot be 0. See, even power will always give you positive sign. So that is only giving this as x less than 0. The numerator has to be 0. Then only this whole will be 0. Now x less than 0 means what? I told you the domain was negative 1 to infinity. Because 1 plus x cannot be invalid value. X by 1 plus x in 1 plus x cannot be invalid value. So it is saying x less than 0. So you can, the domain is -1 to 0. This is the wall. You have to go below 0. So you can just go up to -1. So -1 to 0. This is what is the interval in which it is decreasing. X should belong to -1 to 0 in order to be the function decreasing. From 0 to infinite, I told you that it is actually increasing. Now how you are going to write it? So we have to write it like this. All these mathematical content, writing, the sentences, different symbols have to be used in order to solve this. But before that, domain is important here. This question is totally based on the domain. If you don't know -1 to infinity, that will be a problem. So this is also an important question. Why? See, in this CBSE, it has already come in 2000. So those questions which have come are going to repeat. Now some students will do NCERT. They'll say, I've done everything, but my marks has not come. The question is not from NCERT. That is where the R.D. Sharma and R.S. Agarwal comes. In these books, there are multiple questions, same question with multiple twists and turns. So if you do NCERT first and then you can complete R.D. Sharma or R.S. Agarwal, I'm sure that you'll get complete full marks. That is my guarantee. That is, if you do one thing again and again, you're going to get practiced. And once you are perfect in your practice, you will learn that thing that will be in your subconscious mind. When the question will come in your examination, you will be able to solve it easily. So x plus 2 minus x is increasing or decreasing. We have to tell the intervals. So let us go to the intervals. First thing first is differentiation. We have f dash x. So this differentiation x plus 2 and can be taken as one term. E raised minus x can be taken as another term. So I have differentiated e to the minus x first. Then I'll differentiate x plus 2 in the second one. That is x plus 2 differentiation is 1 only. So what do you get? Just multiply inside. So you are getting this one. Now e raised x minus 2 e raised minus x will be minus e raised minus x. That means this, if you take the last two terms, 1 minus 2 is going to be negative. So it will be minus x e raised minus x minus e raised minus x. What you can do is, you can take e raised minus x common. Minus x minus 1 will be inside. So if it is increasing, f dash x should be greater than 0. Differentiation should be greater than 0. That is e raised minus x minus 1 should be greater than 0. And the second part, see, on Eve, anything power is there, it will always be positive. How? Because e is a constant value. It is 2.174 something. So if you put minus 1 on as the say power or plus 1 as the power, both of the time you are going to get only same positive number. So e raised minus x or whatever happens, it will always be a positive value. It will be always greater than 0. How about minus x minus 1? If you take minus common, this is x plus 1, which is greater than 0. My idea is to multiply both sides by -1. So when you multiply negative on both sides, the inequality sign will change. This greater than will be changed to less than. So now you have x plus 1 less than 0. That is, x should be less than minus 1. X should be less than minus 1. So anything which is less than minus 1, it goes from -1 till minus infinity. So you can just say that x less than minus 1 means we go till minus infinity. So minus infinity to minus 1 is what we got from here. Now the next thing is decrement. That is when the function is decreased. F dash x should be less than 0. What does it mean? E raised minus x minus 1 should be less than 0. When it is less than 0, e raised minus x, as we just discussed, that it will always be positive, whatever be the case. It will always be positive. That is, minus x minus 1 should be less than 0. If you take minus x minus 1 should be less than 0, minus you can take common, x plus 1 less than 0. Now you multiply both sides by -1. When you multiply both sides by -1, what are you going to get? The inequality sign will change. It should be greater than 0. So x plus 1 should be greater than 0. That is, x should be greater than -1. Now when you start with the -1, anything beyond -1 goes up to what? It goes up to infinite. So -1 to infinite is the point or is the interval where this function is going to decrease. So this -1 to infinity I am going to write for the decrement, and negative infinity to -1 I will be writing it for increment. So this -1 to infinite I am writing it here. These are the two intervals on which this function is going to increase or decrease. Important question this is. It is going to come in the examination, please understand that. Now what will be the solution? How are you going to write? Formally. So this is the formal solution which you see here. This is the increasing result, this is the decreasing result, and this is how it has come. Now show that the function f given by fx equals to 10 raised x is increasing for all x. Now this 10 raised x is a very straightforward question, because if you know the differentiation of 10 raised x, that I'm sure you are already knowing it. So a raised x differentiation will be a raised x log a is 10 here. So I'm saying a is 10, so it will be 10 raised x log 10. Now anything on the 10, negative or positive, it will always give you positive. 10 raised minus 1, 10 raised positive, and just check it out. In both the ways, you'll see it is going to be positive. So it is always greater than 0. How about log 10? This is already a constant number. It cannot be negative. It's a positive number. So log 10 is greater than 0. So when plus into plus is there, it is positive. So this is greater than 0. It will always increase. So this is how you are going to write it. There are only few lines you have to write. The logic, if it is clear to you, it will be, you can write more of the lines. You can just say a raise x, differentiation, show it to the examiner, and then you write all these lines. Prove that the function fx x minus this is greatest integer function is increasing in 0 to 1. Now they have made the solution quite easier. This is greatest integer function. This is not modulus, okay? These are square brackets. So if you put any value, if you place any value between 0 and 1, that is just below 1, 0.99999 like that, the greatest integer function will always give you the lower integer. It will always give you 0. So I am just saying that you have 0, 1, 2. Any value below 1 will always give you 0, greatest integer function. Any value between 1 and 2, which is just lower than 2, not equal to 2, will always give you 1. That is, if you put 1.99, it will give you 1. So integral value will come. So I'm just saying that the interval is already given 0 to 1. So just take two numbers, say x1 and x2. I'm saying x1 and x2 are some random numbers we have taken in this interval, 0 to 1. And this x1 and x2 should be between 0 and 1. It should belong to 0 and 1. So x1 is less than x2. That is, x1 is 0, x1 is 1. But 0 and 1, as I'm saying that I'm not taking integers now. I'll take some value which is just lower than 1. It will give you same number. I'm just saying that the greatest integer function is only helpful when you have non-integral value. That is, the integral value, the greatest integer function will always return the same number. Greatest integer of 0 will be 0, greatest integer of 1 will be 1. But we are talking about anything between 0 and 1. So I am saying the greatest integer value function of x1 will be x2. Why? Because we are in interval 0 and 1. So between 0 and 1, you can give any value which is not equal to 1. That will always give you 0. So x1 is less than x2. We started with x1 with less than x2. And I told you the greatest integer function will give you either 0 or 1 if you put a certain value, but it will always give you 0 in this 0 to 1 range if it is not equal to 1. So I'm subtracting these equal because x1 and x2 are equal. You will just argue. You will argue that x1 and x2, they are different. How can you subtract the same different number from the same number in the inequality? So I'm just saying that if you take the greatest integer of 0.5, it will give you 0. 0.9 will give you 0. So that is why this greatest integer function of x1 and x2, which are between 0 and 1, will always be 0. So if you take 9 and 10, I take the greatest integer function of 9.1 and 9.9. It will always give you 9. That is why this greatest integer function they are not different. They are actually equal. So you can equal a equal number from x1 and x2. That is the logic. I hope you got the idea. So this x1 and x2 are the same value. So I hope that whole discussion is clear to you. So x1 minus greatest integer function of x1 is what? It is fx1. The other one is fx2. So when you started with x1 is less than x2, you found that fx1 is less than fx2. So that means this function is increasing in 0 to 1. So this is the logic. Differentiation of greatest integer function will take a lot of effort. It has different signs. So this is the whole idea. I explained you with numbers. If you're able to explain with the numbers, that is also beneficial. But if you have time only in your exam, then only do that. Otherwise, this kind of solution is more than enough, and the logic of differentiation won't work here. X minus greatest integer function differentiation is beyond the scope, right? Now prove that the following function is increasing on R. Now there are certain additions where this question you will not be able to find. There are other questions also which are added somewhere, they are not there. So the basic questions and the idea remains the same. We have fx, so we will take the differentiation. It will be 15 x raised 4 plus 14 to 3 is 120 x square and then 240 here. Now take 15 common because I can see 120 and 240, they both are divisible by 15. So you can take 15 outside. Inside you will get 8 raised 4 plus 8x square plus 16. Now if I tell you that this is a square, just take x square plus 4 and square it. It will be x square plus 16 plus 2 into 4 into x square. So this is x square plus 8x square plus 16. So you can write it as x square plus 4 whole square. Now the logic is clear. 15 is a constant, so no problem with positive, negative. Anything square, you take anything. If you take negative square or plus square, you will always get anything of the even power will always be positive. So this will always be positive, that is f dash x will be greater than 0. So this is how we are going to write, and this is a very straightforward question. And the questions which are coming like this, they also have the same logic. So I will just show you how it is to be done, because it is similar to the previous question. You just have to make it as a perfect square. So 2x minus 3 whole square will always be positive because it is square, and 3 is a constant. So this function is increasing on this real number r. Positive into positive will always be positive. That tells f dash x is greater than 0. Now prove that the function f given by fx equals to log cos x is strictly increasing on negative pi by 2 and strictly decreasing on pi by 2. See, f dash x greater than 0 is increasing, is strictly increasing, and greater than equal to is increasing. So this equality sign will make it as just increasing. If you remove that, that will be strictly. So f dash x will be, I'm just taking the differentiation, 1 by cos x, and cos x will be sin x minus sin x. So it will be negative 10x. Now in between negative pi by 2 and 0, this is strictly increasing and decreasing, strictly decreasing in 0 to pi by 2. Now this make this quadrant figure and mark wherever the sine, cos, tan are positive or negative. So add sugar to coffee, all sine, tan, cos. So all are positive in the first quadrant, and wherever you find out the letter, those letter matching with the trigonometry name, they will be positive. So x is between which two values? X is belonging to negative pi by 2 and 0. So this is pi by 2. This is the mirror opposite. So it is negative pi by 2. So minus pi by 2 to 0 is actually the fourth quadrant. What will be the tan x? Since only cos is positive, it is going to be less than 0. Now multiply both sides by negative 1. When you multiply by negative 1, this less than sign will change to greater than sign. So minus tan x is greater than 0. This is your fx, which is greater than 0. That is between negative pi by 2 and 0. It is strictly increasing. Next one is x belongs to 0 to pi by 2. So we are talking about the first quadrant. All are positive. So tan x will also be positive. Now multiply both sides by negative 1. So the inequality will change. Minus tan x will be, as I multiplied by negative, I am changing the angle sign. That is the inequality sign. Minus tan x is, this is f dash x, which is less than 0. So between 0 and pi by 2, it is decreasing, strictly decreasing actually. It is not less than equal to, so strict. Now this is how we are going to write. So this diagram of add sugar to coffee will immensely help. The examiner will also learn that you learned it, and now you are able to solve the question in light of that knowledge of add sugar to coffee. Prove that the function this is given by, so strictly increasing on r, f dash x should be greater than 0. We are talking about real number. So again, very straightforward question. Just take the differentiation here. This will be 3x square minus, this is 6x, and this is 4. You can take this first term. We are manipulating it so that we can show it that it will always be positive. So if you take 3 common from here, it will be x square minus 2x, and this will be 4. X square minus 2x, I can make it as a perfect square. X minus 1 whole square is what? X square plus 1 minus 2x. So this x square plus 1 minus 2x. So 1 is not there. So when you add a 1, 3 will be added actually, because 3 is already outside. So you have to subtract 3 in order to keep the equilibrium. So if I have added 3, I have to subtract 3. This is what? This is x minus 1 whole square. This is 3 plus 4 minus 3 is 1. This is 3 is a constant, 1 is a constant. How about x minus 1 whole square? This will always be positive because it is square. So this function will always be greater than 0, strictly increasing. Now how you are going to write about it? These are the ways you can write. Prove that the function fx equals to cos x is strictly decreasing in 0 pi, strictly increasing in pi to pi, neither increasing nor decreasing in 0 to 2 pi. So whatever you have learned up till now or completed question, this question is also based on that. First, this is add sugar to coffee. That means in first quadrant all will be positive, others sine, tan, cos respectively in the quadrants. First we are taking f dash x, I am taking the differentiation, it is negative sine x. Now when we have this negative sine x in 0 to pi, this is 0 to pi. Now all are positive here. Sine x will be positive here. It will be greater than 0. Multiply both sides by negative 1. It will be minus sin x which is less than 0, because the inequality will change. So minus sin x less than 0, that is f dash x less than 0, that is it is strictly decreasing in 0 to pi. Now coming to the second part, pi to 2 pi we are talking. So this is pi, this is pi. So 0, pi by 2, pi, 3 pi by 2, and then 2 pi. So we are going from pi to 2 pi, that is third and fourth quadrant. Third and fourth quadrant we are talking about. In the third and fourth quadrant, only tan and cos are positive. It will be, this sign will be negative here. It will be negative. So sin x will be, see, it is less than 0 in pi and 2 pi. That is very important. Multiply both sides by negative 1, you will get minus sin x. This is greater than 0 because you have multiplied both sides by negative 1. So f dash x is greater than 0. So it is between pi and 2 pi. So this is increasing now. So when you combine these two, that is 0 to pi and pi by 2, if it is combined from 0 to 2 pi, from negative infinity to infinity, I am talking about an imaginary line. If this is 0, this is pi, 0 pi and 2 pi, because pi is simply 22 by 7. So you can mark it, and to explain, you can just find it out that whether we are talking about any number which is higher or lower. So 0 to pi, this function is actually decreasing, and between pi and 2 pi, this function, as we have already explained, that it is greater than 0 or increasing. So between 0 and 2 pi, which is the combined interval of 0 to pi to 2 pi, in this combined interval, this is somewhere increasing, somewhere decreasing. So it is neither increasing nor decreasing. So this is how we are going to do this. These are 3 parts. So first differentiate, and on the basis of differentiation and the intervals, just try to explain how you are going to solve this. These are the way. And please remember that diagram should be very helpful. Show that fx equals to x square minus x sin x is an increasing function on 0 to pi by 2. So we need to differentiate it first. Let us differentiate it. So this is f dash x. This will be, x square will be 2x. And x sin x will be what? X cos x plus sin x. So I have applied the product rule here. 2x minus x cos x minus sin x. This is f dash x. Coming to add sugar to coffee again, 0 to pi by 2 we are talking about. That is, in all the terms in 0 to pi by 2, they are positive. So if you take sin and cos, it is this, the value is between 0 to pi by 2. These are the two, you can say, interval or boundary. So sin 0 is 0, sin pi by 2 is 1. So sin is between 0 and 1. How about cos 0? Cos pi by 2? It is between 1 and 0. So you can see it is between 1 and 0, 1 and 0. Alright, so you have x, if it is between 0 and pi by 2, sin x is between 0 and 1. Cos x is what? Cos x is also between 0 and 1. I told you 0 and pi by 2 are the interval. So when we have sin x and cos x, both are positive, and you are going to put any value of x which is between 0 and pi by 2, which is again positive. So 2 into positive minus positive into positive minus positive is going to be what? It will be, so this x is also between 0 to pi by 2. And please remember, this cos x and sin x will always be between 0 and 1, not because actual range of cos x and sin x is negative 1 to 1. But here between 0 and pi by 2, if you put all this value, f dash x should be greater than 0. Only between 0 and pi by 2 I am talking about. So we can strictly say that this is going to be greater than 0, as we observe and as the value of 6 sin and cos vary. Now how are we going to solve it? So this is, writing is very important, which I explained you. Find the values of a for which this fx equals to x cube minus ax is an increasing function on R. So this is a very simple question. You just differentiate it. I am taking f dash x, which is differentiation of this is 3x square minus a. Now you have to show that it is an increasing function on R. So f dash x should be greater than 0. That is 3x square minus a should be greater than 0. Increasing. Greater than equal, because it is strictly increasing is always greater than 0. Normal increasing is greater than equal to 0. So when we take this inequality, a is coming less than equal to 3x square. Now you tell me what will be the minimum value of x, because when you are taking a less than equal to 3x square, tell me what will be the lowest value of x square, because 3 is a constant, x can vary any value. These are the real number, and since we are talking not about x can take any number, but x square can take only positive number, so it will always be positive. And what is the lowest number which you can have? 0. Okay, so a less than equal to 3 into 0, so a should be less than equal to 0. I am saying that we are talking about real numbers. Then we square the real number. Real number squared means all positive number, means 0 to infinity, any number can be there. So what is the lowest number possible in this x square, which is 0. So I use the lowest number in x square, which is 0. So 3 into 0 is 0. So a should be less than equal to 0. This is the whole logic. This function will be increasing in this case. less than equal to 0. So this is how are we going to write. So there are questions where various questions have already come in the examination. So you need to be very careful while solving them. Find the values of b for which the function fx equals to sin x minus bx plus c is decreasing on R. So we'll just differentiate this f dash x. Sin x is cos x minus b, and this is 0. So cos x minus b is decreasing. So cos x f dash x should be less than 0. That means cos x minus b less than 0. Cos x should be less than b. But we need certain value. We cannot just say that, oh, b should be having this relationship with cos x. Now cos x will be between what? Cos x can be between -1 and 1. Since b is greater than cos x can be between -1 and 1. So just tell me what will be the value of b, because b is greater than cos x. Highest value of cos x is what? It's 1. What is the lowest value? -1. So you have to use a value of cos x, which I just told you, between -1 and 1. So there has to be some value which has to be put it here. Cos x, again I am reiterating, minimum is -1. Cos can only produce -1. Cos can only produce highest as 1. So this is decreasing. So I'm just using equal to, just to re-emphasize that it is not strictly decreasing, it is decreasing only. So that is b should be greater than equal to 1. What is the highest value of cos? Which is 1. So b should be greater than equal to 1, because b is greater than equal to cos, and cos has the highest value as 1. Now this is how we are going to write about it. And please remember, cos x should be between -1 and 1. This is the whole logic of this question. And since it is greater than cos x, highest value of cos x is 1. That is why it is greater than 1. Now show that the function fx equals to this one is an increasing function of R for all value of a. X plus cos x minus a. First we'll differentiate this. F dash x, it is 1 minus sin x. This is going to be 0. 1 minus sin x. So it is an increasing function. That is 1 minus sin x should be greater than equal to 0. If it is greater than equal to, that is, it is increasing function. So this is how we write, because we have already differentiated it. 1 minus sin x should be greater than equal to 0. So sin x should be between what? Because I'm just taking 1 on other side, or you can say sin x on other side. So sin x is less than equal to 1 in this case. So what do we get? See, I've just changed the sign. Now both the sides, if you see, now there is a slight change. I'll do it here. 1 minus sin x is greater than equal to 0. So I'll just change this. I'm just changing it. Okay. Again, sin x between -1 and 1. This is the better way to approach to solve it. Sin x is between -1 and 1. Now what I'll do is, I'll multiply both sides by -1. When I multiply both sides by -1, what I'm going to get? The inequality signs will change. Less than equal to will be greater than equal to. This is minus 1. This is -1. Now this is, now add just 1, both sides, because we are in a process to get 1 minus sin x. So when you add 1, you will get 1 minus sin x between 1 and 2. Now what is 1 and 2? They both are positive. Means there will be never this 1 minus sin x will get any number which is negative. So it is always greater than or equal to 0. I showed you. First I tried a different approach. Then I told you no. We should go to this approach. So 1 minus sin x is between 1 and 2. So f dash x is greater than equal to 0. Because 1 is greater than 0, 2 is greater than 0. So this is how we are going to write it. So we have different ways we can write. It can be straightforward. It can have all the symbols. And symbols are much appreciated in mathematics. Now this question is somewhat different. F is defined on 0 to 1. X is between 0 to 1 in all the options here. Twice differentiable is an important thing. So we have fx, we have f dash x, and we have f double dash x also. So twice differentiable such that this modulus of fx is less than equal to 1. Now if I do one differentiation, see, fx is there. If I do the differentiation, what you're going to get? Both side differentiation if you do. Keep the modulus on, but differentiate it. It will be right side will be 0. So f dash x should be less than equal to 0. This is the thing which we have, say, taken out from the question. So when the f dash and f double dash will come, you have to follow the Rolle's theorem and Lagrange's mean value theorem, because one more thing is given. f0 equals to f1, fa equal to fb, a is 0, b is 1. So fa equal to fb. So whenever it comes, then also it is f dash c is equal to 0. I am saying that in Rolle's theorem, we always do that. F dash c is equal to 0 if fa equal to fb and the function is differentiable and continuous also. So what do we write normally? What do we write? When we write, it is fb minus fa by b minus a equals to f dash c if we go ahead with the Lagrange's mean value theorem. So this is the relationship I wrote on the basis of Lagrange's mean value theorem. But I'm just changing C with D, you'll see right now. Now f double dash D is also given, f dash double D, it is twice differentiable. So this fb minus fa by b minus a equals to f dash c, I've double differentiated. I've changed C to D because we have already used C. And I told you already f dash c is 0 because it is already in the question. And I gave it 2 explanations for that. So f dash c is 0. So f dash x by x minus c equals to f double dash D. Now one more thing is given, f double dash D, this one. This is less than equal to 1. Double differentiable. So it is double differentiable. It is less than equal to 1. So this f double dash D is less than equal to 1. That means left side is also less than equal to 1. F dash x by x minus c is less than equal to 1. That means f dash x is less than equal to x minus c. But you tell me x and x is varying, c is varying because c is also belonging to 0 to 1. So what will be the highest value of x minus c and lowest value of x minus c? If you have 1 minus 1, it will be 0. Okay, if you have 0 minus 1, it will be minus 1. If you have 1 minus 0, it is going to be 1. So again, it will vary from negative 1 to 1. Alright. So it is less than equal to, and we are taking the modulus, that is we have to take the positive sign only. So we will take only 1. So this f dash c or x is less than. This f dash c or f dash x is less than 1. So f dash x less than 1, this is what we have to prove. So all this Rayleigh theorem and the Lagrange mean value theorem is to be applied so that we get this f dash x should be less than 1. So you need to know these two in order to actually understand and solve this question. So this is the whole process of solving it. You can just follow this. And any problem, just let me know because this is a very typical question. Find the interval in which this fx x into modulus x is increasing or decreasing. So modulus x is x if x is greater than or equal to 0. It is positive. If x is less than 0, then modulus x is going to be negative x. Now this case 1, case 2 we are going to take, one for the positive, one for the negative. And since we are talking about real number, we will take just two parts. One which is greater than 0. Means 0 to infinite, and one which is less than 0. That is negative infinite to 0. So x is greater than or equal to 0, x is less than or equal to 0. So these two cases we have to take. When x is greater than or equal to 0, what are you going to get? Fx is x into, as I told you, modulus x will be positive here, x. So it will be x into x, that is x square. How about here? Fx will be what? X into modulus x. So x is less than 0. So we will take negative x here. So minus x square you will get. Now let us take the differentiation. F dash x now we are going to take. F dash x is what? 2x here. Here minus 2x here. So if till here we have taken both the cases and gone up to the same step. Now this x should be greater than or equal to 0 because case 1 we have specifically taken, we are talking about x greater than 0. So f dash x should be greater than 0. The 2x should be greater than 0, or it should be, take equality sign also. So x should be greater than or equal to 0 because we have divided both sides by 2 here. X is greater than or equal to 0. That is, we are talking about plus here. Now coming to this one. See, above 0 it is increasing. We have established that. Now x less than 0, what is going to get? We are going to get when x is less than 0. So this is just multiply both sides by negative half. The inequality sign will also change. So only x will remain. This minus 2 minus half will get cancelled. This 0 into something with 0. So x is less than 0. When you have x less than 0, one time I told you x is greater than or equal to 0 for x greater than 0, and for x less than 0, again x less than 0 we got. I hope you got the idea. That f dash x, see, the first case f dash x is greater than 0 when x is greater than or equal to 0. So on the right 0 to infinity it is increasing, and on left it is decreasing. So it is neither increasing nor decreasing. So there are two solutions which I can show you. Second one is a more compact one. Here directly we have differentiated and show that x greater than 0 or x less than 0. X greater than 0 is 0, it is increasing, otherwise it is decreasing. So increasing and decreasing both time, that is why it is neither increasing nor decreasing. Or you can say f is increasing for x belongs to R for these intervals. Find the interval in which this fx is increasing or decreasing, sin x plus modulus of sin x. We are talking about 0 to 2 pi. Now how to find out this sin x is going to be positive or not? This is add sugar to coffee, and we know which all places or in which all quadrants these are going to be positive or negative. So 0, pi by 2, pi, 3 pi by 2 and 2 pi. So this is where we go the anti-clockwise direction. Now if you take first quadrant and second quadrant, sign will be positive. So case 1 will take, we are going to take 0 to pi, the first part. And between 0 to pi it is positive. Case 2 will take x belongs to pi to 2 pi. So we are going to the clockwise direction below the that is the negative y axis. So f dash x we are taking. We are just taking fx right now. So what is modulus of sin x? I told you between 0 and pi it's going to be positive sin x. But between pi and 2 pi, it is going to be negative sin x. I hope you got the idea. So when we are talking about 0 to pi, we will take sin x only. Modulus of sin x will be sin x only. So it will be 2 sin x. But here when we take fx equals to, because we are talking about pi and 2 pi, in between this is going to be negative sin x. So negative sin x minus sin x. So the right part of the case 2, between pi and 2 pi, it is going to be 0. If you take the differentiation, it will be 0. So f dash x should be greater than or equal to 0. You are getting 0. So it is increasing here. The logic wise it is increasing because it is greater than or equal to 0. So equal to we have got. Let us come back to the left side. So let us take differentiation here. So this 2 cos x. So f dash should be greater than 0. This is only possible when we have 2 cos x equals to 0. So 2 cos x greater than 0 means if you divide both sides by 2, you will get cos x greater than 0. Cos x is greater than 0. Where do you get cos x greater than 0? Cos is positive here at first quadrant and the fourth quadrant. That is, x should be between first quadrant and fourth quadrant. So 0 to pi by 2 it is increasing. It is negative here, it is negative here, it is positive. So this is between where? I am talking about positive right now because we cannot go beyond 0 to pi. Case 1 is only between 0 to pi. Please remember. So you cannot take 3 pi by 2 to 2 pi because it is out of the bound because we have taken the case 1 as 0 to pi only. And the case second we have already got that f dash x is increasing. So x equals to 0 to pi. Pi by 2 it is increasing, and case 2 also we saw that it is greater than or equal to 0. Now 0 to pi by 2 it is increasing, but pi by 2 to pi it is decreasing. That is, x belongs to pi by 2 to pi. Here it is 0 to pi by 2 it is increasing, pi by 2 to pi it is decreasing. Because cos is negative there. So one time it is increasing, one time it is decreasing between 0 and pi. So between 0 to pi, that is 0 to pi by 2 it is increasing, pi by 2 to pi it is decreasing. So it is neither increasing nor decreasing. What I am trying to say here is, this is 0, this is pi by 2, this is pi, this is 3 pi by 2, and this is 2 pi. So I told you between 0 to pi by 2 it is increasing. 0 pi by 2 to pi it is decreasing. Then pi to 2 pi as you got this f dash x which is 0, which is greater than or equal to 0. So it is increasing. So sometime it is increasing, sometime it is decreasing. So it means that between 0 and 2 pi, this function sin x plus mod sin x is neither increasing nor decreasing. So how are we going to write it? This is the whole procedure we are going to write it. Alright. And please do remember to make the diagram. That by diagram will make it easier. Find the interval in which the following this thing is increasing, decreasing between 0 and pi by 2. First we'll do the differentiation here. What will be the differentiation? F dash x. This is sin x. Now let us differentiate 1 plus cos x. It is going to be minus, cos x is minus sin x. Now 1 plus cos x you can write just like this. Differentiation of sin x will be cos x. So this is going to be minus sin square x. Now multiply this 1 plus cos x with cos x. So cos x plus cos square x. Now this sin square x you can write it as, because sin square plus cos square is 1. So sin square will be 1 minus cos square. You have a negative here, so multiply with negative. It will be cos square minus 1. Now just write it here. Cos square minus 1 plus cos x plus cos square. So 2 cos square x plus cos x minus 1. Now 2 cos square x plus cos minus 1. This is a perfect square. No, we can take the factor now because it is not a perfect square. 2x square, I am saying x is cos x. So let us make this as 2x square plus x minus 1. We will replace x by cos x just now. So this 2x square plus 2x minus x minus 1. You can take 2 common here, 2x common here. You will get x plus 1 here. You can take minus 1 common here, x plus 1 here. So you have 2x minus 1 and x plus 1. These are the two things. So what are you going to get? See, this is f dash x we have found out. So this, in order to increase this, first let me write the factors here. 2 cos x minus 1 and x plus 1. So I am taking case 1 where f dash x should be greater than equal to 0 or greater than 0. So greater than 0 means both should be positive or both should be negative. So even if you take both positive or both negative, you are going to end up with the same solution. Same scenario you are going to get. That means 2 cos x minus 1 should be greater than 0 and x plus 1 should be greater than 0. This x is actually cos x. So let me replace it by cos x. So cos x plus 1 is greater than 0. So from here you get cos x is greater than half, and here you will get cos x should be greater than minus 1 because it is cos x plus 1 greater than minus 1. So cos x is greater than half. Cos x value vary from where to where? It is minus 1 to 1. So if it is greater than 0, it has to go from half to 1. So cos 0 is 0, cos pi by 3 is half. So the highest number is 1. So you have to start from pi by 3 and go up to 0. That is 0 to pi by 3 is the range where cos x is greater than half. Coming to the right one, cos x is greater than minus 1. It has to be between 0 to pi by 2 because cos 0 is 1. Or cos pi by 2 is what? 0. So you are going to go above -1. That is only possible when you are going from 0 to 2, 0 to 1. Because as I said, cos x is always between -1 and 0. So you are talking about 0 to 1. Say this cos x is greater than -1. That is the angle is 0 to pi by 2. You are here. So we have two parts here. And these two parts are saying what? See here. This is 0, pi by 3. This is pi by 2. So this is 0 to pi by 3. This range we are talking about. Second range is saying 0 to pi by 2. And we have to take the intersection because they both are going to give one solution. So this is the common part 0 to pi by 3. So x is between 0 to pi by 3 where this function is going to get increment or it is increasing. First part is over. Now let us come to the second part, which is f dash x should be less than 0. Same thing, 2 cos x. If you remember just now, 2 cos x minus 1 and cos x plus 1 should be less than 0. So in less than 0, 1 can be positive, 1 can be negative, and vice versa or otherwise. So you can take 1 as positive, 1 as negative, or the otherwise, because the answer is going to come same, because the interval we have to find out. So I'm taking the second case. So 2 cos x minus 1 should be less than 0 and cos x plus 1 should be greater than 0. And here I already told you cos x was greater than -1 and you know the range was or the interval was 0 to pi by 2. This we have established just now we have established. So cos x here is less than half. So I just told you cos x is less than half means 0 to pi by 3 I told you. We are talking about 0 to pi by 2 here. So if I make this line 0 to pi by 3 and pi by 2. So this is saying cos x is greater than half. We are talking about this range. Cos less than half means it was pi by 3 to pi by 2. So cos x greater than half I just told you in the previous just a few moments ago. But cos x less than half means we are talking about this one, pi by 3 and pi by 2, because cos pi by 2 is 0 and cos pi by 3 is half. So x should belong to pi by 3 and pi by 2. And what about here? Again number line. So we are talking about 0, pi by 3, pi by 2. So pi by 3, pi by 2 here. The first solution is this one. Second solution is what? 0 to pi by 2. This is 1. And what is the common one? Which is pi by 3 to pi by 2. So x belongs to pi by 3 to pi by 2, where this function is doing the decrement, decreasing. First one was x belongs to 0 to pi by 3, and the second part of the question we got, it's this one. So this is the solution and this is the reference you can follow to solve it. It's not very tricky, only the angles you should know, and in NCERT it has already come many a times. Okay, thank you so much. This 17.2 is finished now. Take care.